Maybe.
At Hell's Kitchen.
Ah, I see.
I should probably like not leak stuff as well. Hey,
Not link stuff? Why is that?
leak,
Oh,
leak like
leak stuff.
tabs, all my tabs,
It's just
my.
Wikipedia tabs, isn't it?
It's mostly just Wikipedia tabs.
Yeah, I was gonna say, like, what are you gonna leak?
I have the Nuremberg trials tab currently open. So that's a little controversial, right?
You can just wait.
I
How
have
do
none
you
of it.
section your screens a specific way, or did it just go back and forth, just whatever? Because then you could
I
just put
really just
your
have what I want on my left screen, and my right screen's more of a glance over reference thing.
okay. Because I was
But
wondering if
I,
like your
yeah,
work tab, like your current work tab, would just be free anyway, or like free enough. It didn't have your other stuff. I don't know. Question mark.
oh no, I have everything in one window.
In one window.
Yeah, like all my tabs, in the same like browser window.
Oh yeah, that does that. But also like your paint is
Oh right, yeah, yeah,
just
yeah,
like paint.
yeah. No, that's
So it's
always on my
whatnot.
right hand side.
Hi Rainy,
Oh,
hi Scholar. Why are you doing maths? This is literally my whole degree.
yeah, why
Like
are you doing maths?
my degree is maths. Why? Um, so I can help other people do maths, basically. Maybe that's really what it is. It's so that like other people don't have to suffer as much. I'm like putting myself through this so that. That sounds too heroic. Never mind. I don't want to talk myself up like that. Torture himself. It's not torture. It's fun. Just wait till we start. It'll be fun. Big Bio and thanks for
That
being my
is really
study
gonna show
buddy.
us something.
No problem. Ah yes, fun, right? So this first question.
Give it
Right,
curve.
get right into it because why not? Uh, so I was like, okay, cool. Express the position, velocity, and acceleration in terms of the local unit vectors, blah blah blah. I should probably like screenshot this. Or like snip this one. So that we can
Yeah, yeah.
jump the textbook for stuff.
Yes. I should
Uh-huh.
open the textbook too.
Yes, handy. The curvature and the torsion, which I found formulas for online because apparently there's other forms of the formulas which are actually usable. The ones that were given are kind of
Right.
like not usable. And the speed of the particle given interpretation result of the particle's acceleration expressed blind terms of unit. Okay, so I made them in terms of the local unit vectors. I don't know if that's helpful.
Yep, we're jumping straight into it.
That's what it looks like to me. That's what it feels like, because that's what they're defined as, right? It's the
Yeah,
it's what do you call it? R dashed on the magnitude of R. And like, surely we didn't do this wrong, because when we did the mastery check, we had to like reduce this to 1, and it was fine, right?
yeah.
Um, I'm like, surely there's a reason for using the system, but I don't see it if this is what it comes out to be. I also don't know if this is right or not. Right, NT is P dashed on the magnitude. Is it magnitude
See
T or
that's from the
magnitude?
unit vector.
Yes. So
Up.
is it
Right.
this like So this comes from here. This one comes from here, and then this
Yeah, I
one is
think
this. Is it the second derivatives thing? Because
yeah,
that's
right.
here, right?
Yeah, yeah,
Yeah,
yeah,
I figured so. And I don't think you can reduce that to anything.
No, I don't think we
Nice.
do. We have solutions to this?
No, I don't think so. Hold on, let me check.
Something feels. It feels too messy to be right.
Yeah, right. And I don't know like what this does. This represent. This represents position, right? There'd be position vectors. So then you'd have to differentiate these. I'm like, no. And like, this is a set of vectors, right? That describe. Like, isn't this its own like system, like outside of AJK? So you wouldn't be using those in this, but like, it feels like that. I don't know. Like, in terms
Yeah,
of
I'd rewrite RT as
these.
just a like list of things, right?
So
Let me scroll
how
through
do
it.
you? Yeah, I don't know. I don't really understand how to. Let me quickly check what the solutions were up to last time.
Yep.
I'm pretty sure it was just chapter 4's stuff. So chapter 5 stuff will come out tomorrow. Oh, not the Hollow Chapter 5, but this set here, that this top set, the supplementary. We did the mastery checks for this, which were actually really nice. He went through another what do you call it? Because people weren't up to it yet.
Yeah. Cause you're
What
ahead.
was it? Yeah, I know, great, right? The scalar potential thing, and I was like, yes, we got it right. And then I asked him about some stuff. Oh, on that actually, you know how we were talking about how C is unique or not unique, and we were confused about it.
Yep.
So the restriction Z is not equal to 0, right?
Yep.
C could be different above and below the plane. The constant can vary based on
Yeah,
whether or
yeah.
not it's above or below. Which I was like,
Cool.
oh, that's a
Yep.
cool thing. Like I would not have figured that out, but that
Yep.
makes sense now. I understand why he asked that.
Yeah. If we were given a like solid example, well, we could have
Mm,
plotted it. It would have been really obvious.
yeah, 100%. But that's what it was. So there we go. Let's see. Supplementary questions. Yeah, this is all just
What were these
chapter
things
4.
to find?
What is the thing defined?
Yeah, where's P and T and?
That's in section A, I think. Vector valued functions. It's just like the second,
Okay, I'm not back
fourth
far enough.
definition. Fourth definition.
I was scrolling and scrolling. I was like, I don't recognize any of this stuff.
What you're listening to? It's just the playlist I have set up for streams. I do need to add some stuff to it. Like I realized I don't have enough Mario Galaxy themes. Those are good. I'll add more to it at some point. But it's just something that I just add to over it, like over the past time. So then it's good for like these random chill streams where we're chatting or whatnot. It's all over the place. No idea what you're doing, so I'm just gonna sit here and eat cookies. Absolutely nothing wrong with that because
We have no idea what we're doing either.
we have no idea what we're doing. This is technically third year maths, third year uni maths, so you're not expected to know unless you're doing a maths course like me and you're like in second or third year. Even though I'm in second year. Hi Bruno. You used to be good at linear algebra. Linear algebra is fun. Multivariable calculus is difficult. I'm Eggman from Sonic Adventure 2. Hi Grass. Aw. So kind. All the pet. Have to write 2 bio essays in an hour. Good luck, Karini. Boy oh boy. So yeah, since it's defined as
Yeah, I would read
yeah,
in terms of like just a list of things rather than with the IJK. That feels weird.
like
XT comma YT comma ZT.
right, but the reason for expressing it like this is because you can do that. So it's this, and then this is the first one, blah
Yeah,
blah blah. But like that's the same thing, isn't it?
yeah.
But then what? I don't know.
I just hate that notation. I'm very biased against it.
Yeah, no, that's fair. It's just
The only time it's
yeah.
okay is doing cross products.
For cross products, I just use the vector form because I can see the cross. They say cross product. I'm like, you do the thing across, take across, and like they're like that could be really hard to do. So you do the determinant thing. I'm like,
That is sick. I've never seen that.
I don't think anyone sees it, which is the weirdest thing. I'm like, you just cross, take cross, and then you do it again. You do cross up here, cross down here.
Yeah.
I'm like, everyone does the determinant thing, but you can literally just see it.
Yeah, that's sick.
Dang, okay, I guess I'm gonna be really good at oh, there's not much matrix stuff. Oh no, there's vector stuff in year 12. There is vector stuff in like highest maths, so I'll be able to tell people that. Just as Yoshi wanna be puts a child in the tower button. Ah, I see. Not for an assignment though, that's good. This is almost an art stream if you think about it. It is. Art, definitely.
I should open.
Yeah, I just don't know what this is. Just ridiculous. What is this? What am I gonna use this for?
Circling back to tricks, though.
Hmm.
Do you know about the like sun and cos tricks?
Hold on, let me open your pop out your stream so everyone can see. So this is Xernix's window, as you can see up here. It says Xernix's screen. Okay, here. What are these tricks?
So you've got like a few key angles, right? 0, pi on 4, pi on 4, yeah. Pi on 3.
Mm-hmm.
Hang to
Yes.
and probably just pi.
Just
Yeah.
multiples of those. Oh yeah, pi. Yep.
So 0, 1, 2, 3, 4, 4, 3, 2, 1, 0.
Hmm.
And you take the square roots of everything. And then divide everything by 2.
Oh, no way.
Yeah.
No. What the heck?
Yeah, how cool is that?
Wait. Oh my
I may
gosh,
have
that
got these are
literally
in increasing order
works.
too.
That's
Yeah.
so cool.
This is like my favorite trick to teach the first years.
Oh, that's wonderful. Thank you, thank you.
And then 10 is just like sun on plus, obviously.
Yeah, yeah, that's right. Oh my gosh, that's beautiful.
It's pretty good.
Makes out time was simply adding after juice. Oh no.
Like I don't remember the triangle things at all. What is it?
What is this triangle
Visibly
thing?
1,
Draw a
2,
circle, literally draw a circle and draw the sines and cosines. Oh, so that we could like
Yeah,
see
yeah.
that this is no, I can see this is true. I know he's not lying.
What's the other
It's
triangle?
0, 1, blah blah blah. Also,
No, there's
Protota?
one.
Protota? I did not say hi earlier. I apologize, but yes, hello. Sokotoa. Sokotoa is very useful. Sometimes I forget which one is which. Because in physics, I'm like, this thing is here, and like, what does that even mean? So I'm like, this is the opposite one. It's like, Hi, Humberto. No, that 10th grade. Wait, what? I'm the Inquisition. Please stop this mess and come next week to my islet. Oh, I was gonna. I was about to read that as legendary algebra. Linear algebra. 10th grade. Yes, wonderful. We are book club today. Very nice.
It is.
Look, you got him to draw the angles.
No, it's pi on 6. Not pi.
Oh yeah, that's right. That is pounds. Yeah, then that's pound 4. The next one.
You know, is. Yeah, okay.
And then that one's pound 3.
That must mean this one's pi on 2 then, right?
Yes, because it's 0 at that point. Yeah.
4, 3, 2, 1. Hang on. 6, 4.
Makes me glad to take pure. No, this is cool stuff. This one is cool. This one's a cool trick. You can use this from like, I don't know, 11th grade? Is that when they teach trick? I think it is. Well, focus on concept art. Almost non-existent on the pre-Tetris, so there's like 2 pages. Oh. Legendary indeed, the last exam of LA to pass. You got this, Humberto. Ah, made the whole book. That's so good. Very nice trick though. I like this.
Mine. Oh,
Yes.
Yeah. I don't remember the triangles. Who cares about the triangles? Geometry? Yeah.
That's fine. Now, can you draw... Actually, I don't think there was ever like a representation of what these TN... Oh, no, there was, but like, I can't really... Like, they do it here, I'm like...
So T is just the tangent, right?
Yeah, T is the tangent, and it's the normal. B is the one that goes up from them. It's the Z
Yeah,
one.
the cross-product of them.
But I don't understand, like, how you write these in a way that they're functional and usable. Because then...
Yeah, I don't either.
Right?
Like, they clearly form a basis.
Yes, that's right. And then you have, like, kappa defined in them and torsion defined in them, and it's like, that's cool. But, like, this stuff looks extremely weird to calculate. Oh, well, the kappa looks okay, but, like, this torsion, look at this. I have to put this over here and do some stupid, like, rearrangement. It doesn't make any sense to me. I don't understand. They define a right-hand coordinate system. The system moves and changes as t increases. I don't... What does this... Am I missing something here? Like, is this... I don't understand. What does this mean? This just seems...
I kind of feel like anything we did yesterday helped with this question.
Hmm?
I don't feel like anything we did yesterday, day before.
No, this is completely different. Oh, hello.
Yep.
I'll put this up on the other side for now. until unless, and then you can let me know if you're doing anything.
Yeah.
Um, Someone who owns the digital version of the book sent me those pages so I can access them simply on the computer rather than the physical book. Oh, for anatomy, very cool. That's very cool. So I like to draw stuff when doing maths. See, the problem is everything's 3D now, so it's really difficult to see.
Yeah, I
Oh,
can't.
difficult to draw. Like you. Here, I can literally even just. I don't know. We need new paint. Paint. Like, oh my gosh, I can't even make it intersect properly.
No,
It's
that's
like,
not-
well, yeah, there's a thing. It's like here's a curve, and I'm like, where does it project? Like,
Yeah.
like this is it projects in this region, so it's like boo 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 boo. Like this or something. Oh, I can actually see that. But like, I don't know how to project like this axis or whatever. Like that this is like that's X and Y, and then how do you like do Z? Like how do you represent height? Especially when you have stuff like over here and it's like here and it's like it's projected here, but then I don't know. It's weird. My teacher wanted us to know that by heart, and people that didn't know got to sit 2 hours after school. Wow, sad. Calculations are goofy, yeah. It's like the toilet in the test. Goodness. But I do that. Well, I'm glad it helps you, Bruno. For me, I can't. For the life of me. That's why we use GeoGebra. Yeah, no, absolutely. It's good to draw stuff. It's very good for evaluating like for regions of integrals and stuff, and finding bounds. I 100% need it, otherwise I would never be able to do it.
What page is that on?
Hmm. What page is it on?
Oh, no, I'm just clicking around.
Ah, yeah.
Pages. What page was our question on? Because I didn't take it.
Our question.
Found it. Hit the cap.
Yeah, nice. Protein synthesis. That's fancy sounding. Wonder if like there's anywhere that's defined with. I don't know.
Oh, is this the last chapter of the book?
Yeah, it's really long. It's literally the second half of this course is just vector calculus. That was it. Can you express T, N, and B in terms of like nicer things of this or something? Because the formula I found, so this is the other finding I had. Um,
Alright.
oh, hold on. I think I have it here. No, I don't remember. Which one was it? Yeah, so I found that what do you call K is it's actually not a function of T. I don't know why it's written as a function of T in the book. Well, I mean it is, but like it's also I guess it's just to remind you, but it's not technically a set whatever. Anyway, yeah, I found these formulas for what is this again? Curvature? Is it? I don't know. Thing and torsion. And yeah, these are actually things I can compute because I did that. So I did this question. But
Cool.
I don't know if T N and B can be expressed in a way that like is actually readable.
Yeah.
Because I mean, to be fair, this is kind of ugly too.
It's
But
not exactly pretty.
no, it's not. But it's doable, definitely doable. But this just doesn't look doable. What am I gonna do with this? Do they calculate the integrals by hand in the exam? Do they let you? What does that mean? Everything in K is a function of T, so K is also a variable in it? Oh, okay. Hold on. Hmm. I think my main gripe was that this is scalar valued. So it should just be a thing by itself. And here they make it without a function as not being a function of T, so I don't know. Weird.
You know, kappa is not a function of t, is it?
Yeah, right? I didn't think so.
Where's my function?
What are they called again? What is kappa?
No, they do define
It's
kappa as
kappa,
a
sure.
function of t.
Yeah, right? Here. But then down here they don't say it is, and
Yeah.
it's just weird. Alright, confusing. Hmm. One part of it consists is clearly noted as functions of t. I suppose. To take a generalized version. That's kind of goofy. Also, a lot of these are vectors I just haven't drawn in there. It's like a lot of these are vectors. When I'm doing this on the screen, I'm not showing that they are.
It's clear from context.
Huh?
Oh, it's like always a thing that's said to allow like nice lazy notation.
I did not hear it because I have background noise and it's difficult to hear, so I don't know. Maybe we'll repeat it after it's finished background noising. Read about the pages I mentioned? Hold on, did I? No. Oh, what the heck? That's so good. They've got such good resources. I did read about the above stuff. Very useful, though. Would you happen to know anyone who has the digital version, then? Is the question. As long as it's not Mickey Mouse. What? Like math if I do it because I want to, but when it comes to big groups, my brain goes no. Ah, fair. Would mention stuff like there's already a scan out there of the whole book, so there are people out there. Ah, gotcha. Said it was goofy. Oh, of course. Don't know how to contact. Ah, I see. Hopefully you can get your hands under there. I don't know. Maybe there's some info online of this system.
I've already googled.
Nothing.
I can't find anything.
The Frenet framework. Have you like looked at from this name?
The what framework?
Frenet. 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 Yes. Just need those 2 pages. That's fair. Making a lot of calculation mistakes. That's fair. Come to Mike. What?
Yeah, your mic's a little. That's
Weird.
paper, that's also paper.
Frenet. Frenet Seret formulas. Ah. Describe the kinematic properties of a particle moving along a continuous differential curve in 3-dimensional Euclidean space. Thank you. Okay, so that's a thing. Yes, right. Defined as follows. As follows. Curvature measures the failure of a curve to be a straight line. I like that. The failure of a curve to be a so it measures the failure of a curve to be planar.
You have failed to be a straight line.
Oh, jeez. Oh, the sound in the background? Okay. Yeah, no, that's a hairdryer. It's very loud. So, that's why I couldn't hear Zonex earlier. It's still going though, so okay. They define these and these, of course, yes, but yep, and they kind of have a nice relation to curvature and torsion, but
So further down, there seems to be better definitions of N and B. A bit further. Keep going. Alright, it's quite a long way further.
huh?
Keep going.
Keep going. Hold on.
Keep going.
Over here, like, okay, so that's just a specific. Okay, title expansion, congruence in cars, other
That one.
expansion. Oh, this one?
Yeah, somewhere in there I feel like is our answer.
Because this takes a similar form to um yeah, this is where the explicit versions for curvature and torsion are.
Hmm.
Yeah. Okay. Yeah, it may be awkward to work with in practice. Hmm.
You don't. Oh, I just read Graham Schmidt.
Apply Graham Smith.
Yep. That's definitely not going to be something we do.
The thing is, how? No, wait, isn't this the definitions we use? It is, isn't it?
Yeah.
R-T on magnitude R-T T dash T. But then it's this form here, is it?
Hang on, I'm.
Does this help? I don't know if
not
this
sure.
helps. I don't know if it helps.
Yeah, I don't know. Hey, it feels like this is closest. This is better than anything else I found.
Maybe this can help too. Let's see, what is this? Can you get better for the resources? Oh my goodness.
What is a Q clove?
Why is it comma? Why are you not dotting? Why is it comma? Okay.
Because it's an inner product,
What?
and the standard inner product would be a dot. So it's a generalization of the dot product.
That's weird.
Yep.
Oh, okay, I don't know what this Q thing is. So... Hmm...
So what's the next question?
Huh. 5.2 was... Oh my gosh, where?
Page 3 or 4.
304. So this is where we I think just use the formulas. So honestly, I think that one is
that
okay.
one's much easier.
That one was okay, and I did the first one, and I'm like, that's probably enough, right? Like this is, I think,
Yeah,
just
like,
shows it,
this
the
is just
process.
monkey work.
Yeah, I think. Save. Wait, what did I edit? No, maybe I don't want to save it. Alright, I'll just delete this then. 5.9. What is that? For the C1...
No, we're not gonna do that. This is actually really easy.
Is it?
I don't know. It possibly just expand both sides and hope it just all works out.
Sounds good, Hamburger. Thanks for the help. Have fun. Verify that gradient cos F cos R. What the heck? How do you even... What is this?
Must be a field in
C1.
yeah, but I was gonna say R3.
Hmm. Oh my
Because the
gosh.
cross product defined and it's only defined for like certain dimensions.
Did you say R3? I'm still struggling to hear because it is still really loud. Can you hear it?
Who's nah.
I,
Who's blue drying their hair?
that is my sister. Because she obviously, of course, she showered late again.
Yep,
So
no, that's
it's, you know, having to hear this at this time. Hmm.
Hang on, she showered at 10 o'clock like a normal person. What do you want about?
No. She should be asleep by now.
Oh, no, she's 12, 14.
She's 14.
Yeah, 14. Fine. You were probably staying up all night as a 14-year-old.
No, I wasn't actually.
I don't believe you.
I was staying up till... Is that when I was able to stay up till 10? 10:30 maybe.
Oh, she's still got plenty of time. It's not even 10 there yet.
Oh well. Oh well. Guess I'm just bad. Alright, I can actually hear you now. Amazing.
Woo! Now she just starts like yelling in German.
Structured essays over unstructured ones? Oh no. 14 hours sleep at like 2 a.m? Oh jeez. Alright, so you were saying it was in R3 because cross products only defined in R3, yeah?
Cross product's only defined in certain dimensions, and R3 is the one that would make sense. I think it's defined in R7 as well.
What the heck? That's weird.
Like, I
Oh,
think it's just 2 to
huh.
the n minus 1. Or starting
Oh,
at
fascinating.
3.
That's weird.
The
So, how the heck do I...
Nope.
It was a hairdryer, the noise
according to
cancelling was doing
Wikipedia.
funny with your voice mixed with the noise. Ah, I see.
Yeah. The cross product of two vectors, A and B, is defined only in 3 dimensions. That is definitely wrong.
Ah, okay, there you go. Okay.
7-dimensional cross product. Like, on the page, it says there's a 7-dimensional cross product.
What the heck? They're not using that brain.
No, but it's definitely a 3-dimensional.
Okay, so you can write it out, and then write this one out, and then just see if they
Yeah,
equal,
yeah.
I suppose.
Yeah, there's possibly going to be, like, weirdness happening on the right-hand side to simplify to the left-hand side, though.
Right? That's a bit of a... How...
Like, f dot r del that.
Okay, maybe this one's worth giving it a try.
Yeah.
Maybe. This one I don't know, maybe
I
I'll
have
have
no
to...
idea. Like,
I really
ask
don't know.
about it. Yeah, I don't even know what the, like, end thing is going to look like.
The end thing, did you say?
Yeah, what are we, like, aiming for, even with that first
Yeah, I
question?
don't know. That is weird.
Like, are we trying to write r equals something times t plus something else times n plus something else times
Right?
t?
Like, it feels like if that's the system... That's the way the system would work.
Yeah.
But, like, it's... I don't know, that's weird. Alright, I'll chuck this into a new paint.
Yep, I'll be back in 2 seconds. I need
Yeah.
the bathroom.
Do I save this? I don't... Again, I don't. Okay. Let's just keep it. Alright, hi Dragon Sage. Welcome. Fun times. What graphics tablet do you have? My mouse. What you doing? It's uni work. It's a bit difficult. Usually I'm just doing it with Xanax, but I was like, give you guys a comfy stream. And I might stream it a bit more often as a result. Hi Andy. Okay. So F is field. How is F defined? It's a vector field, right? So is it... How are vector fields defined again? I don't... Because there's vector functions. What is a vector field defined like? I don't... What is the general form of a vector field? Oh, it is just okay. No, it is. So it's oops. You don't need this anymore, actually.
I'm back.
Hello. So f is, in general, um, fx1,
Yeah.
fx2. Ah, no, not x. It's just f1. Just a function of x, y, and z. Or it could just be
Yeah.
parameter or whatever. It's
Yeah.
this um f2 of the same. Oh, sorry, f1, f2 of that f3. They're vectors as well.
Yep.
Yeah, cool. Perfect Tensai Calculus going to do can't get ready for AP Calc. Let me know if you need any help, Tatsbook. I would love to help and not feel helpless. Memories of high school when you had to do this? No way you had to do this in high school. No, this is third year third year uni maths. Unless you're like crazy stuff. Yeah, no, this is not high school. Like unless your high school was very advanced, it's crazy. So many cross products, right? This is crazy. So, although this cross product, like these are very well defined already in the
Yeah.
textbook, which is nice. But how would I even write this? Like f1, f2, f3, or should I expand the left side first?
No, I think start on the right side.
Okay. So
Right side's
this
probably gonna be messier,
take
right?
so this dot represent. Hold on, I've got it written down here. Oh yeah, that's right. It's partial f1, partial x, partial f2, partial y, and partial f3,
Yeah.
partial z.
Yeah, because
Cool.
it's just a dot product of partial with respect to x, partial with respect to y, partial with respect to z
Yep.
of f.
What is r?
R is a parameterization of some curve, I assume.
So r is equal to, so just um how are they related? A field and a curve.
I assume that's just like. Oh, I was gonna say xt, yt, zt, but maybe not.
Right? Like it feels like that would be right.
How do you? What's the operation between the vector you've already written and r though?
See, yeah, it feels like it should be a scalar. Oh, this is a scalar though. Wait, no.
Oh yeah, that's a plus,
Hold on.
right? Yeah. Those are pluses. That's not a vector.
Oh,
Because that's
you're
a dot product.
wait.
It's
Oh, that's
scalar
right.
from
No,
plus
this
del
this
x.
this is the
Plus del
gradient
x.
of a
Yeah.
thing, not
Yep.
not the actual.
Yep.
Yeah,
Yep.
no, you're right. In that case, what is the operation with this then?
That's just
Oh, it's
standard
just a
scalar
scalar then.
multiplication.
Okay. Oh, I need my notes on this as well. Let me
Yeah,
just flick
man,
to that.
this is gonna get messy.
Where are my notes?
Your,
Oh,
your
I
voice
figured
is
out the whole
just
like
gone. Your voice.
vector field. Oh, you go.
I was gonna say your voice has gone weird, but it went back to being normal again.
That's funny. I figured out that the whole relation between those random things about the conservative vector field, you know how the
Yep.
partial derivatives were equal to each other, it's the same as saying the curl is 0, and the curl is this.
Yeah.
Um, and I looked at the formula and I was like, oh, if you equate them, because one is for the I, one is for the J, and one is for the K. Each set of the like blah take blah.
Right.
So they have to equate each other, which was a cool little thing. Um, so there's that.
Remember how I was gonna price a cake?
No.
I should like go to bed probably no later than 2 o'clock my time as well.
Ah,
Because
well,
I
I'm
have to
not
be up.
staying up like that late doing
Okay,
this.
cool.
That's okay.
Just Just making sure.
Yeah.
Because yeah, gotta be up to make the broth tomorrow.
Yeah.
For the ramen on Thursday.
If you get a graphics tablet, don't do like my chem teacher did and spill coffee on it and then proceed to continue to use it while it's not functioning properly. Oh jeez. Divergence of coil? Yeah, that's alright. That's the sort of stuff that I'm tackling now. Um...
You had an open bracket XT, YT, ZT, I think.
Right. So what kind of is it just scaling this? I guess it is.
Yeah, yeah,
But
because
that
that's
feels
just a
weird.
number, right?
Yeah, okay. Oh, I have no idea how this is gonna relate to the
Yeah,
left hand
no way.
side. Plus the gradient, which is and then the dot product is a thing.
Yes.
Gradient
This
this dot this.
is F plus X of T. I
Yeah.
have no idea if we're doing this right. This feels dodgy.
Right.
F1 XT.
Plus F2.
YT.
And then you'd be taking the derivatives of this as well, which is
Yeah.
I have no idea if that helps at all.
Hey, what are we taking the derivative of?
It would be the partial derivatives of whatever's in here, one with respect to x, one with respect to y,
but like
and one with respect to z.
F1 X of T, F1 times X of T.
Is that
When we
a
differentiate that with respect to X,
is that a
X of T
product
just
rule?
stays constant.
Oh, hold on, yeah.
Or is R just some arbitrary vector?
Yeah, I don't really understand. What is R?
I'm gonna scroll back through the previous question. Like ours are always used as a curve.
Right, yeah, because we've already seen R of,
Yeah, I was just
and this
making
is a
sure it was, like,
parameter. T is a parameter
consistently
of this.
doing
Yeah, I don't know. It's weird. I don't really understand how to interpret it. The right's equal to, hold on, R cross curl of F? I don't think that's the curl of F. F cross R, that seems different. But right is F take R. Yes, that is the divergence of F. That one is divergence of F, sure, 100%. Plus the gradient of the dot product between a vector field and a curve, which is weird. I don't know what what a dot product between a vector field and a curve produces, but apparently that's a thing. Take R times, yes, R cross the curl of F. So that is the curl of F. That is indeed. The value of curl can be evaluated by using the matrix determinant value rule. Yes, you can do the cross product. Or rather, the curl can be written in a certain way, but it doesn't look very clean. Right, it does feel like this parameterization would just be a constant in this term, in each of these, which feels weird though. Is R? Where do they use R? Ah, they use it here. Okay, so do they? The R is just a vector x, y, z.
Oh,
That makes stuff way easier.
it does.
It's not even a parameterization of a curve. It's just literally a vector. Okay, because that means all that is we're taking the derivative of
F times X. That's fine.
yeah.
That's easy. That's just the product rule.
Yeah, that is just product rule. Easy peasy. Alright, cool. Let's rewrite this then. Hi, Joe. Useful identities. Yep. I'm gonna be using the gradient cross F cross R. So I actually have no idea what this is for.
So,
I'm so curious.
no one at no like math students at my uni remembers this stuff because we never use it in later courses, and we teach this stuff in second year.
Yeah,
Like it just doesn't come up.
that's just silly.
I assume it's like useful in physicsy stuff. Oh,
Yeah, all this like vector, like flux and whatnot sounds very physicsy. But also,
yeah.
this is like the last maths thing that you learn, so unless you go into higher fields and like very advanced physics, I imagine you would tackle
Yeah, I
this
don't know.
at all. Take R cross.
May learn this stuff
Should I?
before you learn like special or general relativity, maybe? I don't know.
Oh my gosh, do I have to write out the code? Guess I do.
Probably like copy chat out.
Oh, you can write it out as a vector. The code is a vector, hey. Yeah, it is. Maybe it's useful to write it out as a vector. I just realized I could just
Yeah, I was not paying attention.
take,
That's why I didn't have this one. Yes.
take, so we figured out what this is as well. This is not, it's whatever. Take R
But they
cross.
cost 300k. How did you never notice?
Actually, hold on. Let's write out R. X, Y, Z cross product with. Oh my gosh, this is a huge vector though. Oh my gosh. Can't. D. Okay, so that's what we're working with.
And that obviously equals the left hand side. QED.
I really have no idea how this would work out.
How do we simplify this? Do we just expand out the
Everything.
yeah?
Stuff surely
Do we
cancels,
expand
right?
out the left hand side to like see how we're gonna make them meet?
I wonder about that.
Yeah, I think that's what we do.
Here's here's one thing I'm thinking about. I'm seeing how like if you're taking the derivative of this, then when you product rule this out, this is the same as this, right? And they're gonna cancel.
Yeah.
It seems like strictly the gradient is a scalar product of the del operator and a function. Yes, that makes sense. That makes sense.
The del f1x plus f2x plus f3x should be x, y, and z instead of x, x, x.
Oh, what the heck am I doing? Okay. This you paint, I guess. Okay, so I'm gonna just where did it go? There we go. I'll put this on the screen for a moment, just so I can copy stuff. So expand this out is what we're saying.
Yeah, that way we can like
I think this seems like pretty expandable.
yeah.
Was
Like-
this
So my thinking for doing this is we have our start and end point, and we are trying to get them to meet in the middle.
Yes, that absolutely makes sense to me.
Cool.
So this is blah F1, F2, F3 cross X, Y, Z, which is cross this vector, which is going to be Z F2 take Y F3 X F3 take Z F1 and Y F1 take X F2. And then if we're taking the that's then the curl of this funny thing, which is how loud. So it's D or del del Y. So it's del of this. So there's gonna be a lot of this. Take del of sorry, this is big vector. It's a vector of all of this. We don't need to write it out in IJK notation. Bunch of trash. Thank you for the follow.
Joe, I agree.
I feel that. What did Joe say?
This is, as far as I can tell, pointless busy work.
It feels like it, but like I don't know. Weird relation, isn't it? But I feel that unless seem pretty cool. Thank you.
Like, there's
do
no
my
way you're
best.
ever gonna remember this.
No. I think
As in,
it's
like,
sort
you're
of
not gonna remember the identity.
doing this is sort of a familiarity exercise with me,
Yeah,
remembering that this is the
yeah.
call and this is how you write out the call. That's kind of helping me right now. But also, I'm also just curious with how it works, which is, you know, the death, like that's terrible. I really am too curious and too happy to just go explore trash. So, so you get this, and then you get the other two.
Yeah, hang on. Have you seen the Wikipedia page for the curl?
No.
Give that an open for a second and scroll down to the second picture on the page.
Hold on. Do you have it linked?
Hang on. I can
Mhm.
click over. This picture. What?
Oh, hold on. Let me open your thing. I thought you had your thing on. Instead of, I was
Yeah.
like, oh, open the link. I was like, no, I don't need to. So, wait. What?
This picture here.
Oh my goodness.
That apparently encodes what the curl is.
That is a catastrophe. Why is this a thing? So this is the representation I'm going for as well. The thing at the bottom, in case anyone was curious.
This.
The one that it expands into, yeah, in the vector form.
Yeah.
Yeah. That's what I was writing out, but that, I don't know, that's weird.
Whee!
Beautiful. A work of art.
Yep.
Line integrals of closed curves. Yeah, the integrals are maybe where the fun actually happens. And the stuff that I need for my assignment. But
Complex is so much better. You just got like nice theorems around integrals.
that's fun, right?
Complex is pretty good.
What up?
I don't remember most complex analysis.
Ah.
Like integrals are just nice. You have the residue theorem, and everything just works out because it's all like nice.
That sounds pleasant. Now, can you see how
Yep.
this relates to what we had before?
No, no, I can't at all.
So we had
Um,
this. How does this even like work? I don't even understand what this does. Like, how do you do anything with this vector? So does everything become that vector? I guess you collect all the
yeah,
components, and then it'll somehow.
like
How
the
do you get
left
it?
hand side's gonna simplify real nice, I think, because
This doesn't do anything, does it? I don't see it doing anything. Or
like
do you
the
take these derivatives?
yeah, I think if you take these derivatives, you'll end up with
Mm,
something relatively okay.
okay, so take those derivatives.
I've heard the curl is like sticking the water wheel in your vector field, and if you stick it in perpendicular to the curl, it'll spin the fastest.
That's interesting.
Cool.
No, I think. That's a cool way to put it. So for example, if we took this with respect to y, that's then f1
It's
plus y. This is just f1 with respect to y. Like this is still a function of x, y, z, but like it's f1, which I guess is a simplified version of writing this, which is
yeah, I think it's just a nicer way to write it
okay. Yeah, that's fair.
because we've got rid of the x component of it, right? As in, like we got rid of that minus x too.
Oh, this one here.
No, the
This
other
one.
one. Yeah,
Wait.
haven't we? When we differentiate that with respect to y.
F is still a
No,
function
we
of y,
haven't. Yeah, we
so this will
haven't.
still be xf2.
Yeah, yeah.
Differentiate with respect to y. This looks ridiculous.
We're definitely in the half of like vector calculus. I don't understand. In 5 minutes, I'll break through and okay.
Mm. Plus. You get 2f1. Like. And I guess you can group the terms.
Yeah, yeah.
Sort of. Yeah. Hold on. If we. Oh. Plus. Z f1 with respect to z. Greater r is 111. It's indeed 111. Yes. Partial x, partial y, partial z. That's 111. Yes. Is that used anywhere? Oh, if I flip back to. No, we never take the gradient of r here. Well, this is the first time seeing that vector r, but I just remembered a student put in their solution to an exam problem. Now I understand.
Why do you understand?
Yeah, right? Why don't we understand? Help. Man.
Vector calculus identities. There's a looking for. Holy crap!
Huh?
Um.
What's going on here?
So, Wikipedia. Are you looking at my?
Oh, yeah, you're right. Oh my gosh, I keep. Vector calculus identities. Okay.
Look at them all.
Why are there so many? And people
Right.
think trig is bad.
Right. Alright, moving it away from my screen again.
That's all the fun stuff. Oh, I guess. Hold on, I'll have it like. I don't know. Yeah, R, we were confused about that too, and then I flicked back to these vector identities, and R here just represents just a vector x, y, z. So that's a gradient.
That, like, used V.
V, yeah, right. That would have been logical. Gradient of f cross r. Oh! Are we using these identities to... No, no, no. We're proving one, right? So we can't use any others? Question mark?
No, we should be able to use them.
Yeah, right?
I thought of it, but I didn't really want to.
But now it's just like, it's not gonna make any other sense otherwise, right?
Maybe.
Maybe? I don't know. What are we even trying to verify? So we're trying to verify for the C1 field. Okay, I don't think those bottom ones are relevant to our discussion. I don't know, we can put it here. Okay.
What are we doing? The del of f cross a vector.
Right, does this give us any insight? Do you have the properties of the cross product you can use? Properties of the cross product. Properties... It doesn't ring a bell. But it might be something that can be pointed out and still make sense. Oh. Hmm. I'm not seeing it. Shower and stuff sounds good, grass. Enjoy. Bye bye. Hmm. I don't know. Rule 6. Here F and G are vector fields. Whereas this is a vector field cross a vector, unless there's some I don't see any relations here that. Hmm. Not seeing it at all. Hmm. Are these all 5A? Because then we wouldn't need 5B. No, 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 this is surely 5. No, 5B because we don't get introduced effect fields until this. Um, what are we trying to do? How we... Oh, hold on. What does C defined as?
It's a
They...
constant.
Ah, constant
And
vector.
see it's a constant vector.
Hmm. Yeah, some of these make sense. And then some of
That's
them are just like, what?
that's good. Did it? Some of them make sense. Field plus vector.
So, how does... No, hold on. No, never mind, never mind, never mind. I don't... How does this fit together at all? Hi, Shocky. How's it going? Oh my gosh. I need to pop in. Wait, you said 9, right? Oh my gosh, 10:30 is not. Ah, I'm sorry, Shocky. I failed you. I failed. Hope you slept well though. Hey, look, Tom, what are those triangles doing there? Yeah. Yeah, I don't know. I think they've lost their minds too. Math book was really probably needs a Yeah, I'm feeling that too. It's okay. Oh. Oh, what the heck? I wonder how Stan feels about these. Man, maybe we should wait for tomorrow for these ones in particular. Because I don't know if we're gonna find any sort of sense in this. Well, Hasa, once everything's good, it's good to hear. Knowledge of multivariable calc is from Khan Academy doesn't do any help to these nasty questions. Yeah, I don't know. It's everywhere. There's no sense to be had, and I assume you. I don't know, Joe. You seem to know stuff, considering you described code to us and everything. So, right? It does feel kind of goofy. All right. Well, I suppose for these ones, I'll wait till tomorrow then, for the solutions to come out.
Yeah.
I don't. Whatever.
Well, what's the cross product? Oh, well, what's the
Hmm?
F cross R? No, hang on. Is that what I care about? No. What do I care about?
Hmm.
Hang on. Let me. What's the divergence of just a vector?
Of a vector.
Divergence of vector.
So it would be del dot a vector is 3. Oh no, it's well for xyz, the vector xyz, it's just 3 because it's partial derivative with respect to x, y, and then z, so it's just 1 plus 1 plus 1 is 3. So it's just it's thing. 10 is easy though. See, yeah, like easy enough. Yes, that one I could actually see, and it's like, oh, well, that's fine.
So flick back to paint for a second.
Also, the curl of the divergence is like that's funny. Which page? The paint?
The paint, yeah.
Yeah, this one.
That one. You ended up with a 2F1.
Hmm. correction with a bio class teacher put the wrong link and we have no way to contact her. Oh jeez. 8 is easy if you use the determinant definition. 8. This one. Ah. So that's blah dot. Hmm. True single set determinant 0. I'm doing alright, Rainy. How about you? Linearly dependent. Linearly dependent. What have you done up until this point in the class? We've just been doing a lot of. Well, it was a multivariable calculus. It sure was. Here, here's the. Let's go to the contents. Here we go. We had vectors and functions. Um, we've had differentiation, partial derivatives, gradient, more derivatives, chain rule, implicit functions, Taylor stuff. That was fine. Applications, so extreme values, which is fine. Other extreme stuff, yeah, that was fine. We didn't actually do the rest of this, which is so whatever.
The three squares. So it's like, yeah, you'll do this in another class. For every class.
Oh my goodness. Multiple integrals, lots of integrals, improper integrals, changing variables, changing order of integration, big integrals, and this is what we're studying now. Now it's just vector stuff. This material is beautifully geometric. I get the feeling you're doing a lot of algebraic manipulations. I see a fair amount of the stuff that's happening, but even with that visualization, I think I'm not seeing it enough. Like, I can't... It's hard to look at these identities and sort of see where they come from, if that makes sense. Like, in a geometric sense. Because I can definitely understand that. It's been pushed a fair amount. That drawing is very useful, right? And it is. It looks to be. Oh, this material should be presented geometrically. That stuff in the textbook should be represented geometrically. Like, there is a lot of diagrams, and like, there is a lot of illustration. But the vector calculus, yeah, I have noticed that this part in particular has been a bit lacking on the diagram. You're right. Like, they show some of the stuff that they've defined, like the NTB system was shown. I still don't understand how you use it. Oh, were you here when we looked at this? Because if you have any idea how this works, that's fun. Maybe, I don't know. Maybe it helps, but I see how it works, but I have no idea what this definition does for us. Or how you can use it. Someday you have to explain this to me, please. I'm curious now. Rainy, if I ever get to the point where I can explain this to someone...
So, in hope that you will at some point get to the point where you can explain it to someone.
Okay.
We struggled with the first 4 chapters, right? And now looking back, we are confident that you can do it all.
Oh, yeah, to be fair, I do feel like more of it's making sense. I think
Yeah.
it still hasn't clicked completely. Like, there's still some loose stuff. But
Yeah.
for the most part, like, I can look at something. Like,
Yeah.
I've become fairly confident with it.
And what, this is day 2 or 3 or something of, like, looking at chapter 5 stuff.
That's true.
Like, we're not that deep into chapter 5 stuff yet.
To be fair, the last couple bits of chapter 5 are just gonna be theorems that help us, like, evaluate some integrals, from what I can tell. Which is sort of, I don't know.
Yeah, I feel like the early part of chapter 5 is the hard bit. Like, that's
Yeah,
where all the concepts
see,
seem to be.
like, I think I could definitely feel that in a lot of the other chapters as well. Like, chapter 1, even, like learning about all the stuff that constitutes multivariable calc. It's sort of
Yeah.
like being introduced to a new course altogether, right? This is just
Yeah, yeah.
the rough part. And I realized that, like, I think eventually, yeah, I'll get this. And I'll try and explain it to you, Rainy, if you're really that curious. But yeah, it's just this hump is quite difficult to get over.
Yeah.
It's just very, very, like, notation heavy.
It is,
And
I
the
agree.
visualization has just become crazy, right? Like,
Yeah, yeah.
3 dimensions is difficult.
Indeed.
Yeah. Credit frame, yeah, exactly. That's what we were confused about, because it seemed like using these definitions. Oh, here's what I was drawing up
There's
earlier.
unit tangent vector everywhere on the curve. The change of that unit tangent can't point in the same direction as t, otherwise t would be getting longer, i.e. not unit length anymore, right? Thus n only points in the direction the path is turning and is perpendicular to t.
Okay, hold on. Let me reread that. That's also hi to gamer and maybe can't point in the same direction as t, otherwise t would be getting longer. Ah, yes, of course. Okay, that makes sense. Once you have two perpendicular vectors, you're most of the way right.
Yeah.
And B is just defined as that cross product, which makes sense. 100%. Right.
So why is n gotta be perpendicular to t? Like I'm totally sold on it being in the direction it's turning. What's definition? Not 240.
The change of the unit tangent can't point in the same direction, or t would be getting longer.
Yep. Oh, right, and that's why it's gonna be perpendicular. Yep, yep. All right, I understand. Oh yeah, you can't have any component of the vector in that direction.
Yes.
Yep.
Yes.
Yep.
So the first... What? No, this is not right. This is the wrong thing. Oh, you know what? I'm just gonna here. Which one was it? This one. This one! It was telling me to define them using this framework. That just seems kind of ridiculous. It's a proper plane to find n in general? Okay. Be back?
Yeah, I'll be back.
Alright, no worries. So this question was... Okay, so given a C2 curve in R3 representing the trajectory of a particle described by the parameter duration, this is blah, express the position, velocity, and acceleration of the particle in terms of the local unit vectors t, n, and b, right? And I think the expression for the position would be given by just the definitions of what t, n, and b are given by, like, if you're given a parameterization and then you're, taking those derivatives and whatnot. But all it did was, it made this mess, and I'm like, is that really anything? And then if it wants me to find the velocity and the acceleration, wouldn't it just be the derivatives of each of these? Or rather, it's the derivative of the vector. No, I don't know. Because this is a 3x1, right? This single vector within this framework and this normal vector is a 3x1, right? And that's meant to define the position. And then if you wanted to find the velocity, it would be each of these derivatives or something. I don't... It's not fitting together. Apart from maths, what was your favorite subject in school? What was my second favorite? Psychology. That's what my psychology was my second choice as well.
I am back. Oh,
Psychology was
are we doing
awesome.
psychology? I have a
Psychology is
Wikipedia
cool.
tab for this.
Oh no, let's. Rainy was asking what my second favorite subject was, and psychology has to be it. Psychology was so good. I
Okay,
still
that's
love
fair.
psychology. We talk about it on stream all the time, so that gives
When you say
everyone
we
more
talk
reason.
about it, you mean I ramble about it, and
You ramble about it, and I sometimes give you discussion
you put up with it.
points. Okay, sure. I expected physics for some reason. I mean, this is... Oh,
Physics and
physics, no, actually. Physics was... I didn't take physics in year 11, 12 at all. And then I realized, oh, I should probably take physics in uni and do it as a minor. And also, like, I'll probably teach maths a bit better if I can give people some applications. Like,
well, there's other applications than just the physics one.
oh, absolutely. But I think that was the most familiar path for me.
Yeah.
It's the closest link that I could see. Considering you do a tiny bit of physics and maths in year 12
Yeah, yeah.
as well. It just felt logical. And down the line, maybe I'll do more um, of applied maths and see that there's
Yeah.
see more to do with it. But for now, I'm just taking physics as the minor. Psychology, it's absolutely amazing, right? It's so good. Physics, mostly maths and theory, yeah, yeah. Except more as well. And also, the textbook for it is...
Garbage.
It's funny. Anyway, I don't know, Joe, if that does anything, but that was just silly stuff. Anyway, did you have a final point to bring up about this? Because otherwise I'll just close these out and we'll have a look at some
No, I don't think so.
extra
I
stuff,
was
yeah.
just looking at other stuff.
It's nice, not
Did
my favorite. That's cool.
did the Australian dollar just like crash relative to the US dollar?
I have no idea.
USD, AUD.
You know what? I'm not even keeping this. It just makes me sad. Okay, so yeah, all of these I'm gonna just put on hold. We're gonna get the solutions tomorrow. So these ones are the stuff, other things for this week, technically. Technically. But like this week we also just in the tutorial. I don't know. For some reason, when we came back from the break, the tutorial became offset by 1 week. So I don't know.
Weird.
Like most courses do it offset by 1 week anyway, because like you learn
Yeah.
the content, you apply it. But then
Yeah.
multivariable calc was always like, oh, watch all the lectures on Monday, then Tuesday you come in for the tutorial. I'm like, I haven't had time to do any questions.
Yep.
Like, that's silly. So this makes more sense, but it's also weird because now it just feels different. Anyway, this is stuff for this week. 5.9, 5.10, 5.11 is when we start actually talking about. Oh, 5.9, oh, that was this verification thing. Wait, 5.10 and 5.8. Are you kidding me? It's just more short. Oh, no, that's mastery tracks. Never mind. Okay, cool. Let's have a look. Maybe this is stuff we can do. The point of the friended frame is that you can reorient yourself relative to the... Right, it's a relative thing, which makes sense. Right, you're moving with the curve. Well, the framework moves with the curve, which makes a lot of sense. Right, I can see that being useful. It's just in algebraic form, it seems weird. Had to think some more about others. That's fair. Position is 0, velocity is t times speed. Gotcha. Yep. Position is... yeah. That's good. So much to do? Yeah, both of us, Shoki. We'll get through it though. Where are the... Hold on, which one are we looking for again? 9, 10, and 11. Okay, so they're all together-ish. Oh, that's 5.5. Yeah, just skipped a bunch of stuff. Sort of. Line integrals. Oh yeah, is this actually stuff we can do then? 5.9. How far in is this? Evaluating curve integrals along curves defined by the intersection of surfaces. Evaluate... What does this even mean again?
I assume that just means along the curve gamma.
Yes, though that's specifically a line integral along gamma. It's closed. Right, that's closed. So it's
Yeah.
circulation. Yeah, it's a circulation of f around that curve. Right? Okay. It's given by this. where f is equal to y I'm still trying to get over this notation of like the what do you call it? The differential being vector
Yeah.
valued or whatever, or like having vector in it. It's like that feels weird to me. I'm still trying to like wrap my head around that as well. Is the gamma is the curve of intersection of the cone and the plane. Okay. Hello, Moss. Thank you for the follow. Much appreciated. Okay. Blue to paint. How do you perform this operation?
I have no idea. Is that just a dot product?
How does...
I have no idea. I don't remember this at all. Well, I guess I can like lean forward and scroll through the notes here. Right. No, that was a silly search. Why did I do that?
So, dr... Right, if you parameterize it, you can do it like this. This is what I'm familiar with. This was gone through during the lecture when you parameterize it. I don't know if there was one that was defined strictly just like this, which is weird. Otherwise, R represents... It's represented how? You have to parameterize the intersection. Oh, is that right?
That makes sense.
Okay.
So did you say you do the workshop for this next week? The tutorial? Or whatever
Yeah,
it is?
yeah. But if I can get ahead on this sort of content, then hopefully the assignment will be soon enough.
Yeah.
Hold on, so if you parameterize it, then you can define it using this expression, right? That's what I'm seeing.
I guess so. How do you take the factorial of an integral?
Except
Of the word integral?
factorial of the word integral. Previous page. I did write that. Good. A function of a vector valued function parameterized with variable t dot the derivative of the parameterized r with respect to t, and then you can take that all as a derivative with respect to t. Okay, slowly.
Alright, so yeah, I think the hub is if you're just parameterizing the code.
Yeah, how the heck do you do any of that? I agree, Shocky and Rainy. Don't even remember how you parameterize stuff now. Where's the discussion on that? Guess and check?
Good guess and check.
Oh. Absolutely, Rainy. I was thinking about it for a little while, because most of the time, like, I am just chilling with Zonix, but if other people want to chip in, I'm absolutely okay with that. So, experienced guessing and checking. Oh boy. They talked about parameterization? Parameterizing. We denote an independent variable by t. The vector function, in general, defines a transformation to a point in Rm. As the independent variable varies, the point traces out a curve in Rm. Okay. From the specific perspective of a particle trajectories, it is usual to replace f with r to reflect the application of vector functions to position in space. We use this notation. Oh, so they just so this is how they. Where does example 4.1 end? Or 5.1 end? Is it just here? They're not even saying what they're doing.
Yeah, for it ends.
It's just is time dependent. T equals this. Woo woo. I guess. I mean, I guess this is the. I guess that's how you parameterize it. But like, what the heck? How?
Flux is just gonna be cos squared t. Nope. Yep. Y is gonna be sin squared t. So it's gonna be 9t minus 1, right?
T equals x2, y choose 2 should be on both surfaces. Enjoy the food, Bruno.
No food. I'll get food after stream.
Ha 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 ha.
Does that work out? That may actually work out, whatever I just said. What did I say?
Hold on. I should probably have the question up too.
It is
Let's
5-9, right?
5. Oh, sorry, mastery track 5-9. Nope,
It's
out
on
of run
page
too far.
268.
268. 5.9. Oh, this one. This one here. Let's snip it. Okay, do I have space to add? Okay.
So I said x equals cos t, y equals sine t, and z equals cos t minus 1.
How the heck do you see any of that?
The cos of t is in brackets. As in, like, in the
Is that?
minus 1's not part of the cos.
Oh, yeah. So,
I have no idea. I haven't actually verified that it satisfies both equations. But it's up to you. So I saw circle. I see the x squared and y squared and see circle, right?
okay. Okay. Yes.
Oh, hang on, that means z is always. No, maybe this is not right.
It contradicts y equals z plus 1, says Joe. Ah.
Oh, hang on. Yeah,
Yeah,
it's
this
sine.
should be a cos, hey?
Right? No, that should. No, the other one. The z should be sine. Surely x is sine.
Wait, but you're
cos.
taking 1 to add 1 here, aren't you? And that becomes 0, right? So y should be equal to z, but then you have that minus 1, so cancel this plus 1.
Yeah, no, I want z to be sine, not a cos.
Oh, okay, you want that one to be sine.
Because the cos is x, right?
Yes, in general, when you do that thing, then it becomes that, yeah. Okay, so
But that still fails if t is like anything, basically. I think it fails that first one.
because this is just 2, right? So z squared
Yeah,
should be
that's
equal to
just
2. Okay. Yep, gotcha. Gotcha.
Which it's not.
Z squared is 2.
So that is not the correct substitution.
Yeah,
Because
no
you
idea
said.
how it's...
Well, if you set z squared equals 2, that means z is root 2, right? But then you've got root 2 plus 1 equals y.
Yeah, that's...
And then y is a
funny.
constant as well. And then only x changes. But that is
Yeah,
definitely
yeah.
not what's happening.
No, absolutely not. How does one do anything?
I should not be stuck in this.
Okay, off topic. My yesterday got beaten 1350. So he beat it by 35 seconds. That's
Wow.
funny.
You didn't
Yeah.
get good.
Nah. I just need to cycle better. Alright, I guess I need to put in actual runs now. That'll be next stream then. We'll go for more attempts.
Alternatively, how long was it? 13 something?
1350? One shot it? 15-minute stream?
Yep, that's what I'm thinking right now.
Easy
We'll just
peasy.
take a 13-minute dirty break.
That's it. Okay, so... Does substituting this in do anything for us, do you think?
Oh.
Oh, if you substitute one of these in, then you can keep that as constant, right? Like in the final parameterization, or like it becomes, I don't know. Oh,
No, you definitely can't keep it constant.
No, you can't.
All three variables.
I'm thinking of like the whole, when you... No, that doesn't make sense. Y equals z plus 1. You know what, let's... Oops. Right.
I feel like I get to be much lazier while I'm streaming. I haven't wrote anything for ages. I'm just like sitting and stuff.
Well, to be fair, a lot of this is just trying to think about it
Yeah.
conceptually, which is a mess. Yeah, I don't know what this does for us. You can write it... This is like a circle... Oh,
Oh, hang on.
right? Can you write it as a circle and then do something with that?
So gets off those things and write.
Wait, what are you
set
looking
in terms of x and set x to
T,
T
you
or-
get z in terms of t,
yeah.
then y is in terms of... Oh my god!
Yeah, try that. I'm gonna throw my bio teacher and a daughter who's a toddler just came and hugged her. That is pretty cute.
Oh, that's wonderful. Right. Okay, so we're writing that t squared is equal to this. Or should it be that...
No, the sets get
X-
blocked, don't
Hmm?
they? Oh, right, never
Z's...
mind.
Z is
You-
equal to t
yeah.
and then x in terms
Sorry,
of
I
t?
didn't realize I totally misread the things.
Wait, no, should we
Oh.
make z equals to t? Does that make more sense? Because then we have x to t. That's not what we were saying the whole time.
I think it makes more sense to use set in terms of t because then it's just going from what
Does it?
0 to 2 or something. I don't know.
X is t. And then, oh, the thing is, this doesn't, like, turn into anything nice. Z? Unless I expand. This is expand, right? Z squared plus 2z plus 1. Yeah, okay.
Yeah, that's right.
And then...
Yeah, no, definitely set as t actually because otherwise you have to solve the quadratic in terms
Okay.
of-
So then that gives us t squared plus 4t plus... Oh, that's not... Oh my gosh, I literally crossed my z's now. Why am I making this mistake still? 2 on 2. And we're taking the square root of that as
Yeah.
x. So that's how z, that's how x. And y equals t plus 1. So it's just the x1 that's kind of... Oh, y equals t plus 1.
And that factors nicely as well, right? That's just t plus. No, it doesn't. I'm an idiot.
Okay.
Perfect. What are we doing? We're gonna integrate that. Yeah.
So that's our point of intersection.
Yeah, we have to take a dot product with.
Bad news, lads. That's not how you do it. That's only half of it. Wait, so this is... Hey, we're in the right direction! Woo!
We did half.
Oh, plus minus, yeah. No, that makes sense.
Oh yeah.
Yeah, that's fine, right? No. That means it can go in either direction. Because it's...
Yeah, it's a circle.
Wait, hold on. But if you restrict... So, and also we need to restrict t to some thing, right? Oh, does that become the bounds? Is the restriction of t the bounds? I don't remember what.
Yep, I think so.
Okay. Cool. So that's 2 expressions. That seems weird.
Oh, there's probably some cool substitution, right?
Hmm.
What's the factor to? Like half of something?
It doesn't look particularly pretty. We could try evaluate it. Maybe the integrand is nice. Because now we have everything we need. Okay.
Yep.
I think
Yep.
let's copy this over and create a new paint because we might. At least we've got the parameterization, which means maybe it'll come out something that actually works. Okay. This is equal to. So it's. Thing is. Oh, we'll see. Just call us out if we made an error in calculation too, but that, I think that was right. The dot of so t plus 1.
Hmm.
I did it with trig functions. See, that seems to make sense to me, but
Yeah.
like I don't know how you can. Unless again, like the whole circle theory seems reasonable. If you set z equals again, like this form we have here, we could make it a circle, and then we could write stuff in terms of. Actually, don't know what you'd write it in terms of, because it only makes sense to me to write stuff in terms of r and theta, but like that's not right. You're trying to find one single parameter,
Yeah.
unless there's some magic trick that you can do that allows you to write it.
I am also on board with not checking that square root mess.
It's this dot, and then it's just a dot of the the derivative of this. Oh, finding the derivative of this is. Can you find the derivative?
I have no idea what our bands are gonna be. Because T
Yeah,
has
also
to
that.
like. Yeah, no, this is definitely not right. Or do we split it up into two integrals where?
It might work eventually. Do you have any guidance? You said you did it with trig functions. Does that mean you actually figured out a way to do thing? The good panic music? Yes, it's true. Yeah. Okay. Hmm.
And I need to unmute your stream to hear what the good panic music is.
Oh, it's the sure. I'll say second half theme. First of the second half themes. It's the. Oh, you broke. Oh, you're going to get to 700 soon, which means you're gonna have a nice stack. Oh
Right,
wait,
yeah.
then the other music starts, and you're like, oh yes, this music,
Yeah, my stack.
and then your stack is at 800, and it was nice, and then it's not nice. I solved the plane for Z and subbed it into the code. Right, which is what we did, right? Oh, but doing it in terms of Z. Okay, so doing with X and Y, which is fine. Right, moved all terms with X and Y to one side and complete the square. Oh, so did you get it like a circle equation? Okay. Let's just put that on hold. Solved it for Z. I've been saying I used to say Z all the time, but now I'm
Yeah, I
saying
know.
Z all the time because
Because I've changed you. I'm taking full responsibility for it. Making you speak like a proper person. One day you'll say wrote as well.
what?
Because I wrote once and you corrected me to written.
Written? No, that's actually English.
Yep.
I think it's because I was saying like del Z or something sounded goofy, so del Z seemed nice, or like something like that, where one of the notations just sounded nice with Z, so I just started saying Z. Ellipse, which is what it looks like if you project it into two variables.
Yeah.
Mm. Yeah, yeah, absolutely. Okay, okay. An ellipse rather, not a circle. Yeah, you're right. Cool. Um, right. Let's do that. Z is equal to so it's 1 take y. Then we have 1 take y squared is equal to 2x squared plus 2y squared. So you're given y take 1. Y equals z plus 1, z equals y take 1. Yeah, good one, good one.
Nailed it.
There you go. Oh my
You should just
goodness.
put a minus sign on the side.
Oh, that would have been great. Genius. Take y squared plus 2y. Take 1 is equal to 0. 2x squared plus y squared plus 2y. Take 1 is equal to 0. Plus y plus 1 squared. Take 1, so that's equal to 2. What happens when you have a 2 here?
Mm.
Oh, that's the ellipse form, right? When you have it as a fraction? When you have one of the terms as a fraction.
Yeah, probably.
I'm pretty sure. Do I have to get 1 on the right? Yes, okay. Right, an ellipse is defined as stuff with fractions equal 1. Yeah, it's equation, equation of ellipse. Equation of ellipse.
I have not been in my degree since 2012. I'm gonna use that as my excuse. I'm definitely not anything to do with teaching stuff.
What?
What?
I have no idea what you just said.
I haven't done any stuff in my degree since 2012. I'm expected to not understand this.
Evidently. Yes, that's right. I remember this now. Equals 1. So ellipse specifically has equals 1. Is a right, and
That
it's
all
blah
it is?
on blah squared, and then 1 squared is our x1, and then b is root 2, I suppose. Okay, so that's... So the... What does this tell us? This is what the intersection looks like? Is it? Because if you're equating them, it's intersection, right? So is it? Are we saying that the intersection
Yeah,
looks?
projecting onto the x and y axis.
Ah, okay.
I'd like to say I came up with that myself, but I just read chat.
Yeah. Use the Pythagorean trig identity. Oh. So are you? Oh. See, I'm seeing that. I'm seeing that it's blah squared plus blah squared 1. Hmm. I don't know what you would do with that. That. Hmm.
Are we just subbing cos and sine in for
X is
x
cos
and
t.
y? Yeah,
Y is
sine t.
uh. See, I don't see how it fits with this one.
Then expanding stuff out, maybe. And we end up with a 2 cos t.
Hmm.
I don't know.
Would you just make x equal cos t for the sake of keeping consistency with what it's usually defined as?
Sure. I don't know.
So then it's all of this junk equals sine, right? Which is like, mm, oh, do you,
Yep.
of course. No, you times by 2, and then you can take 1.
Yeah.
Yeah, well,
Um.
oh, is it square root 2? Oh, yeah, that's right. If you put this all
Yeah.
square, then, yep, that's right. Cool. Yeah, y is equal to root 2 sine t, take 1.
Yeah.
And then you can sub that back in here for z.
Yep.
Really? So z squared, this squared, this squared is equal to 2 this squared plus 2 this squared. I believe that. If you said this squared equals 2 of this squared plus 2 of this squared, I would believe you.
Yep. I don't want to check it.
No, I see it. The sine squared and the cos squared cancel out. You get a from this you get take 2 root 2 blah blah blah, and then you divide out by 2 at some point, because at some point you also get a loose half or something probably. No, yeah, because it's 2 times that. Yes, obviously. It's obviously that, right? And when you square this, you also get this is 2 sine squared t, which also gets divided out. Or rather, 2 sine squared t and 2 cos squared t becomes 1, right?
This is all the cycle and written psychology Wikipedia pages.
And then because of that, you also have a take 1, and there's a take 2 remaining,
You'll take it as a yes.
because I wonder why there's a take 2 remaining. You get a plus 1. Anyway. Sort of. I don't know. I'm playing games when you're doing that, so sometimes I get half of it.
And
It's
just
okay. It's
sitting here,
good for chat.
staying away.
It's good for chat.
Yeah. We're talking about the psych reading, not the math talk, right?
Both of them. It's good for the brain.
Yeah. My brain has definitely gotten smoother.
So-
tonight.
So we were on the right track, because it wasn't circle, but this is ellipse, knowing that this is
Yeah,
ellipse,
yeah,
which
yeah.
is good.
Yeah, yeah.
Which is very
I think
standard
that's not the
still.
ellipse substitution.
Yeah, that one's clever.
Hmm.
That one's clever. So you were right about saying x is cos t.
Yeah, it always supposed to.
Which means we could have plugged that into anywhere and just gotten the values of y and z eventually.
Yeah, I guess so. Oh, I just guess I try to do too much, hey?
So, it seems like parameterizing with trig would be fairly common. But I don't know, it's sort of one of those things as well where it's like, these questions are very, I always forget the word for this, it's such a good word for maths questions. Made up. What's that word?
Ad hoc.
Another word.
Ad hoc? Contrived.
Contrived. That's the word. See, that's a cool word. I like that word. It is. Right? Because it's always... It's always like, oh, it'll work. And
Yep.
sometimes it's really difficult to make it work. And these
Yeah.
questions are definitely difficult to make work. But it'll always be like, oh, you know, it's an equation of ellipse, which is fine, I suppose. And I suppose it's good to train those skills. But it feels so, like, it doesn't feel as satisfying to find this sort of solution, because it's like, in this question, we're going to parameterize it with t squared, t cubed. It's like...
Yeah. Yeah, the examples are never good.
Yeah, right? That's not enough. Again,
Yeah,
there's not enough. That's the main issue here. If there was just more examples of just like literally parameterizing stuff,
yeah.
like, oh my gosh, I could actually do these questions.
I
But
think I have the same complaint about Newcastle here. Like, there's just
examples,
not
lack of
enough.
examples.
Yeah, parameterizing examples in particular.
Ah, no, you haven't talked about that in particular because we just talked about it today.
Yeah, but I have the same complaint about like Newcastle's education on this
Right.
particular topic. Like, it just now we parameterize the curve, and we're never going to explain like how we came up with this.
Yeah, right? That's. So it really is just a matter of intuition, it feels like. Parameterization. There's no standard process.
I guess not.
I suppose I can ask Stan about that next time I see. Gosh!
Yeah,
See, if I'd known this yesterday, I could have asked about it today. Man, I can't
yeah.
do enough at once. We don't get enough contact hours. It's not fair.
Hmm.
Like, we get that one class, and like, we only just.
The Newcastle for third year classes has lective for contact hours, and that's it. They don't have like for tutorials.
What?
Yeah,
What?
yeah. It's garbage.
It's maths. You're
Like
meant to
one of
apply
the
it.
hour or so ish of the 4 hours of contact, maybe 3 hours of contact, is generally like run more as a workshop.
I see. Man.
Yeah, right.
Okay, okay. When I say applying, I mean doing mathematical calculations and stuff. Not actually using it in other fields, because that's ridiculous. Like physics,
Yeah,
psh, that's silly.
everything.
Yeah, but I want to be able to calculate an integral, right? Like, I don't want to just know what an integral represents. Come on, jeez. Because, that's fine. But I want to do the integral. Doing the integral is the fun part.
Contact hours are things where you can talk with your like lecturer or tutor face to face.
Basically, it's just class hours.
Yeah, class hours.
The thing is, with lectures all being pre-recorded for this course, we can't even ask during recordings. Not during lectures, which would be very handy as well. And that's a very unfortunate. Guess I could email him more often. Honestly, like maybe that's something I should be doing more. I've thought about that. It's sort of like maybe I should be emailing more. 'Cause I could just get small clarifications every now and then. But it's also just hard, you know, like
It
to
is
ask a question
very
like this. Oh, this is fine. Questions like this are fine.
Yeah.
It's like, you know, is there a standard way to parameterize stuff? That's fine. But there's a lot of stuff where like you would just need to sit down and do something. Like
Yeah.
office hours.
Like,
Office
it's
hours, I
just-
think is. Oh, you go. You go first.
it's just so good to be able to like write on a whiteboard and get someone to correct you immediately
Absolutely, right?
and
Like
talk
what
about
we
what
do.
your confusion is. Yeah.
And like I
You
really
take
appreciate you because
fucking
you do not do it for like anything. You just do it just cause. I honestly
Yeah,
don't
yeah.
know why you do it. Why do you help me?
Oh, I'm both bored and you're fun to talk to.
Aw. Isn't that
And
nice?
this is like a giant hole in my knowledge. Like I don't know anything about that.
Oh, so it would just be kind of nice in case like anyone
Yeah,
else
yeah.
asks you or something.
Yeah.
Okay, that's fair. Right.
Like you remember how I've talked about our maths clinic a bunch, right?
Yeah, what?
This course, the maths clinic at Newcastle, like where we just
Uh,
volunteer to help students
yes.
who don't know what they're doing. This course almost never gets helped with.
Okay.
Like the math students don't know this course.
Right. Fair enough. Okay, so
Because we never use it later.
Yeah, yeah.
And it's taught poorly. Yeah.
Mm,
Whereas like introduction to vectors and lineage and stuff like that is all easy stuff.
mm.
And we do a lot of it. But yeah, like vector calculus just never gets touched after our vector calculus course.
Yeah, no, that's fair. It's rough.
Maybe in advanced differential equations you touch it, but then that's taught really poorly and you don't see the connections between the two things.
No, I'd imagine so.
So,
Yeah.
yeah.
400 hours per subject? That's ridiculous. See, I suppose it kind of is like that over here. But again, like, lectures being online is one of the worst things because
Yeah.
really, that's where you're being taught the theory, right? Like, and that's the main problem. Like, if we don't understand the theory enough, we can't apply any of it, and then, you know, our tutorials just become explaining stuff. Like today, it was literally just going over like concepts and doing one question on finding the scalar potential, which wasn't that hard anyway. So.
Didn't we have old mate Patrick GMT for that?
Yeah, but like it fits together very nicely. Like I can see it.
Nothing.
Some of this doesn't though. It's just like this equates this and this equates this, and that's nice. That's easy.
I wonder how much harder it would have been to quit last year if we were in person. Because like being online made quitting, like after getting the abuse that I got,
Hmm.
quitting doing online teaching was so much easier than what I think it would have been in person.
Huh.
Because the rapport with the students just wasn't there doing online stuff.
Yeah.
Like
Hmm.
I didn't have that big of a vested interest in them, I guess.
Yeah, yeah.
Like a big emotional vested interest.
Oh, yeah, so it could easily. Yeah, no, totally. It would be easy, I'd say.
Yeah, whereas I probably would have just suffered through the semester
Just to get
if
them through because you feel
yeah,
like
yeah,
yeah.
yeah.
No, I agree. I think so too.
I haven't thought of that until just
Hmm. Let's see here. Our meeting with your teacher where you tackle problems. So
so that's different again for
yes.
us.
So we do have. I assume office hours has the same meaning over here, where it's
Yeah,
sort of
that's
like
office hours
they're
for us.
literally. Well, they would just be in their office, and you can go visit them. You can schedule an
Yeah,
appointment with
yeah.
them. I don't know how frequently they get used up here, which is interesting.
Yeah, they don't get used very often in Newcastle here.
Which I feel like is again like a sort of a thing that I should take upon myself, but it's also I don't feel like I have enough time because there's so many lectures to watch, there's too many
Yeah.
classes to attend, and any time that I'm spending like at uni otherwise is with my friends trying to go through problems together because none of us know what's going on, right? And we can't all barge in and be like, "Hey, can you give us a class?"
Yeah, you
Because
probably can, right?
do you think
Yeah, yeah.
maybe that's
Like
the
I would
play
be
to
totally fine with that if that happened to me.
if a group of students was to
Yeah,
ask
yeah. Yeah, yeah.
to maybe I don't want to overwhelm him. Maybe it's the
Like
best
that's
call
his
though.
job. Like
Yes, that's true. I see. That's one thing that I hear a lot as well, and I see it in my mind. It's sort of like, you're paying for this. You're
you
paying
are
for
paying.
the one of the biggest things you're paying for would be the access to professionals in the field,
Yeah, yeah,
and you're meant
yeah.
to ask questions to them, and you make
Like
use of the hours you have with them. Right?
yeah, yeah. Like I've been over what I think you're paying for when you pay for a uni course, right?
Yeah.
You're paying for the content of the course. You're paying
Yes.
for access to the expert,
a hundred
and you're
percent.
paying for the networking.
Mm.
And you didn't get two of those really last year.
Yeah.
You still had
Exactly.
to pay
Right.
full fee.
And maybe that's why I'm also kind of feeling about things, but you might be right in saying that maybe we all oh, I don't even know what his contact hours are. Maybe I can ask him sometime soon because if we can kind
Like
of,
it does feel really good when students come and ask you questions and are eager as well.
I'd imagine like as someone who enjoys teaching, I think the feeling of having because receiving emails is sort of as well, even getting that
Yeah, it
in-person contact for
yeah, yeah.
as a teaching figure feels like it would be
Yeah, yeah.
very,
And getting to see the students' our face when they understand.
yes, definitely,
That is
definitely.
probably the most rewarding part of teaching.
That's a thought. Okay, you know what? Probably worth giving a shot. I'll talk to my friends tomorrow about that then.
Cool.
Because that's probably our best play if we don't understand. The thing is, we're also still kind of all over the place and offset with our knowledge because,
Yep.
I'm looking ahead with this. There's one other friend who's actually ahead of me now.
Cool.
She's up to week. She's only got the week 12 lectures, whereas I have to still watch week 11 and week 12.
Yeah. Maybe I should watch the lectures for these. So I'm not like just trying to learn on the fly what you know. Do.
I'd be happy to rewatch them with you, honestly, as well.
Yeah.
It might be worth. But like, also if you just want,
Well, I guess I'm busy the next 2 days.
hmm.
I guess I'm not that busy on Thursday until I leave. I have to cut up meat in the morning.
I don't know
That's
how
about
we'd
it.
find the time. Time is half, but like maybe
Yeah.
just rewatching because I have the notes already. So yeah, I guess it just would be a rewatch.
Oh
And
yeah, that's definitely a thing.
I'll
You
just
get
chat
the
now
creative.
because so yes, we do have like hours where the lecturer is just um on campus and they're around and you can talk to them. I think it gets mentioned a lot in first year, and then after that it kind of just they don't tend to say it again, which is
Yeah.
why
Well,
I
you had
haven't
an
felt like I could
atypical
reach out.
first year.
Oh, what?
Like you had a very atypical first year
Hmm.
in that you weren't on campus that much.
Yeah, that's true. Uh,
So you don't really know what the lecturers expect of you, and then
that's true.
they
That
expect
does
you to
make
be
it
a regular
difficult, doesn't
second
it?
year student, and you're not a regular second year student.
It's silly, isn't it? Yeah. Okay. Hmm. Man. All right. Anyway. So yes, they're around for hours, and you can go and like because they don't get many meetings, then most of the time you can't just walk in. From what I recall from last year, because again, this year they haven't. Because last year they would even make it a point, like this is when we're on campus, whereas this year I don't know where any of them are on campus. I don't know where any of their offices are, actually, for that matter. They're probably in, like, this building. Well, they'd be in the math building, obviously. The math building. Um,
Oh, that's cute.
um, actually, maybe
Newcastle, the
maybe
maths
they're not in the
lecturers are
math
not in the
building.
maths building.
Oh my god. Oh, I remember that. Yeah, yeah, gosh. Oh, jeez. Yep, yep. Okay, I remember this. But yes, you can meet with them and such. To recorded lectures, yeah. And the thing is, the students in those classes don't ask much either.
Yep.
Except, can you move the page up?
God damn it, Natalie. God damn it. Was it Natalie?
We still don't know. Her name hasn't come up since, so we'd have to rewatch that specific lecture where it came up like twice. I don't even remember which one it was. Oh, that's funny.
Also, it's like drugs and it's mathematics.
We also had that comment.
That should have been your screen
That was
title.
funny.
Screen
Oh
title.
my gosh. I don't know if Twitch would have liked that. I mean, they probably don't care about me because they're not copywriting. Blah. But anyway, shh. Um, so, uh, what was I gonna say? Yes, right, catch up chat. Yes, I apologize for being a bit slow with this, but I think Zonix has been reading it too, so, yeah. Have problems focusing online? I think that's a lot of people. Yeah, a lot of people can't focus as well online, or like again, it's not as engaging, right? It's you're staring at a screen instead of
Yeah.
staring at a person waving their hands around, writing stuff on a
Yep.
board, and speaking out to you and looking around
Yep.
the room. It's a lot more engaging for most people.
And
So
it's so much easier to get distracted sitting at home with your laptop and everything else
100%.
around you.
There is so much. I have to like you have to be really like. There's the whole thing of being an independent learner already. And
Yeah,
then then you're thrown in even more obstacles, and so it's like
yes.
I need to keep my workplace very, this is my book, this is my pen, I'm writing notes for this lecture. And even
Yeah.
then, sometimes
Having
I just like,
things closed and your phone on the opposite side of the
yeah,
room.
right, you have to throw your phone away, and
Yeah.
it's just like, even then, like sometimes I just feel so tired, right? Because again,
Yeah.
I'm not feeling engaged in the content, so I end
Like
up just not
going to
taking
you like
notes.
yeah. Like going from your house to uni is waking you up and stuff as well.
Yeah, yeah,
Like you're
absolutely.
stretching a little
You're
bit.
getting
Like you're just
out.
naturally stretching a little
Yeah,
bit and
that's
stuff.
right.
Getting a bit of the sun, maybe, hopefully.
Yeah, absolutely.
And work like lectures at home. You can just roll out of bed 3 minutes before your class,
You
go to the
can.
toilet, then
You can. Thank goodness the only one that's
so
like
bad.
has that problem. Or doesn't have a problem because it's nice. It's linear programming network, so it's like, oh, that one's nice.
Yeah,
So
yeah.
at least that one's nice. Uh but yeah, you're right. Full steam lectures no matter where they're located. Okay, fair. Oh, sleep well, Roshoki. Thanks for hanging out. Catch you
Yeah,
soon.
what did you say? Sleep well, Shocky?
No, rest like, extra hours sleep, he said.
Oh, nice.
Yeah, he's getting a bit more sleep. Let's see. Welcome back, Bruno. Welcome back to Maths. Yes. Pleasure of limited 15-minute break between lectures is super useful. Everyone ignores it. Wait, as in... Wait, did you have
I
lectures on lectures before? No way. That's... Ugh.
I wish I could like schedule Newcastle's like classes so there could be a little break between lectures.
Jeez.
Like it's not even hard to do. They just don't know how to linear program. Like
Yeah, that's
they've
just
paid like
ridiculous.
at least in the five figures, like mid five figures,
Mm,
for software that they're almost using correctly, but they're not quite.
mm.
And I'm pretty sure it's just a binary integer linear programming system they're using, or some
Uh,
variation thereof. Um,
sounds
and
simple enough.
like we used to have world-class researchers at our university doing rostering.
Yeah.
And they refused to let those researchers do the like the timetabling for
Oh, that's
the.
ridiculous.
It's like this is like a joke to these people.
Yeah, that's
They're
stupid.
saving the like mining companies because we have like the biggest mining port in Australia.
Yeah.
Um, they were saving those people like millions upon millions of dollars a day,
Of course.
and the uni just like did not care that we had those people in our department.
So stupid.
It would have been like a few hours work, maybe like a day's work for these people,
Mm,
because it's mostly just data collection, and you just go send one of your like honor students off to do data collection.
right. Guess we've got to work around all the silly people's
Yeah,
choices. That's really what it is. A lot of this. Anyhow, hello, LPCM. Welcome, welcome. Hope you're doing well. Sorry again about the delay on these. I'm like, yeah, 8 minutes late now. But I hope you guys are still uh, feeling. I don't know, maybe this discussion isn't that engaging.
You've got me started reading on uni. It's all
See,
your
we're
fault.
engaged. Yeah,
Like,
right?
there's just too many layers of management. The people making decisions are too far removed from the people doing the things with the students.
No, you're right. You're right. We'll get back to that soon. Like, now that we have progress on this, I think we can complete this mastery check, which would be satisfying because we can play the question on the stream and it only took us 2 hours.
Yeah, yeah.
Oh, man. Alright, we'll get back to this thing soon.
Right.
Most professors I know are just sitting in their offices waiting for students. See, that makes sense as well. It's just weird to think about it because I always think about like teachers and they're like always busy marking work and whatever. And it's like, what do the professors do in their
Nothing.
offices? Like, are they literally just in there? Because
It depends what their courses they're teaching is like. So Stan's probably not doing much related to coursework because he wrote the book. But if they're not used to the lectures they're presenting, then they're reading through them and adjusting them to their own personal style a lot of the time.
Gotcha. Right.
Um,
But otherwise, if you're
or
in like so
doing
much control,
research.
right?
Yeah, yeah.
Yes.
If it's well established, like if you've well established a routine for your classes, you don't really have to do that much
It's not
for it.
much work for it. Okay,
Yeah.
that's fair.
But yeah, if you haven't and you're swapping classes a lot, like first year classes get swapped all the time.
Yes, right.
At Newcastle, so every year the notes get changed
Yes,
slightly.
you did be
Those
adapting.
problems never get changed because then you have to make up more problems.
Yeah, of course.
Um, and yeah, um, just then marking and stuff. If
Yeah.
you don't have lackeys marking for you,
Yeah, yeah, right. Well, he's got a lot to
then
mark.
research. Yeah, then research.
Yeah, fair enough. Um, yeah, alright. Again, like this is I keep hearing these things. It's just a matter of like, doing it, which is always sort of tough. I'll have to email
Um,
Stan and check when his hours actually
yeah,
are.
the only time I would like hesitate to interrupt a lecturer or
Hmm.
professor or someone would be in their research time if they've that dedicated time to research
Oh,
because they
okay.
just won't answer the door.
Right.
Like if they're scheduling research time, they don't get much research time, and I would just leave it
Okay,
to wait.
right. But like we
Unless
have
it's
no
like a
notice
really
of that, so
pressing issue.
yeah.
Some lecturers in Newcastle have on a schedule on their door, um, and they
Ah,
do
okay.
do
Yeah.
Western research, and stuff.
Right, but then it's just a matter of, asking about that and that's it. Then you
Yeah,
just
yeah,
walk around it. Okay, cool.
yeah.
Cool. Let's see. Have you seen the Mads meme we posted on Discord? Let's have a look at this. What is this? What did Bruno post? Let's find out.
Where am I looking for this?
Here, I'll pop it up here. Can we have y equals sin x? We have y equals sin x at home. Y equals sin x at home. Yoshi Still's a legend. Ah, you actually want to know why? Wait, this is today. It just makes it even better. Yeah, where's that again? You have a quick retweet. Confused screaming. Yeah, me too. Alright. Thank you, Bruno. Let's see. Who student who comes in with a question is a treat? Oh. See, again, good thoughts. Why are you taking away? Because yeah, right. You need those you need those breaks to brain. Um, you get a better grade if the person knows how hard you. That makes sense as well, right? If you have that sort of context, you'll feel more. Like that's why I feel like with Kevin, he won't be as harsh. I mean, I don't know. I still don't have my grade back for that, so we'll see.
You also get better opportunities if you have a good relationship with
I'd imagine
um
so, right? Because
lecturers and
they'd be
stuff.
more willing to reach out to you for
Yeah, that's right. It's like,
that sort of
hey,
stuff.
there's this like project over summer. Do you want to like work on it?
Yeah, yeah. If they know that you've got
We
an active
we should
interest.
like this stuff. Yeah, that's right.
And it's not even just for the purpose of that, but knowing that that's also a thing is kind of cool.
Yeah.
It's good. ADHD and it's also a pain trying to suppress stim because my camera's on. Yeah, no, that's completely fair. There's not enough in place for people who have that sort of like attention deficiency and such. It's just again bad system. It only caters to. Oh, we've ranted about this. I'm gonna get that started again if I keep this up as well.
Yep.
um,
Uni suck. I hate university.
there you go. Uh, let's see, 8 to 5 p.m. straight. 2 of my lectures ignore 15-minute break. That's stupid. Yeah.
Oh,
Just
when I lectured the algorithms course, I got to uni at like 7:20 a.m. and left after 8 p.m.
oh my
Yeah,
gosh.
because I would lecture at like 8 a.m. and wanted to avoid the 8 a.m. traffic, like the 7:30 traffic for 8
Oh,
a.m.
okay.
starts.
I see. Yeah.
I got there at 7:20, ate a little bit of like breakfast
Sheesh.
because, yeah. Then I tutored someone after their class, like last class
Yeah.
of the day.
You're crazy.
So I was leaving after 8 p.m.
See?
And I was always like rushing to get the stuff done the Tuesday night. So it was a Wednesday, like that was
Yeah, right.
the long day. So I was always up really late on the Tuesday, waking up at 5 o'clock so I could play my hour of Tetris before leaving.
Oh, yeah, right. Oh, you're crazy.
Yeah.
You've
Wednesday's
done a
was
lot
a
of
very
good.
tired day.
Yeah, I'd imagine. Today, 11th of May, or every Tuesday? Wait, what is this about? Oh, right, yep. Okay. Yeah, it is weird. Reason 7, no, yep, that's complete. Joe, I don't know if I've ever asked this before. I'm pretty sure, I swear, you've come in during, like, math streams. I'm like, have you followed from, like, Puyo or something? Or did you follow from, like, just chatting? Like, we met over maths? Or was it, like,
That math stream a few years
I don't
ago.
know. Maybe you don't want to
Although you
answer this,
checked it
but
in volume.
and I probably have asked this before. I swear I've asked about your backstory before. It's like deja vu. It's the weirdest thing. I don't know if I have though. I'm just very curious. Welcome back, Scholar. Hello, Whooper. Oh my gosh, hi. Been long since I've done multivariable code. Wow, another person's actually done stuff. I'm working, but good luck with the way you're studying. Thank you so much. Oh my gosh, no worries. Hold on. I'll get to that in a moment. Hope your work goes well, Whooper. Thank you for popping in today. I really appreciate it. 12 hours school, yeah, crazy stuff. Now watch the Puyo? Right, okay. Do you know about the three-dimensional crossbar? Do you know the only... Something's mentioned this earlier! I can... Oh my gosh, thank you so much for the... so chaotic. That's actually genius. That's a good way to use that. That's so good. Thank you so much for the support. Much love to you. Many hugging. Thank you. For the best is Yoshi. No. You guys are too much. Thank you. Thank you. Lots of squish. A couple years ago? Right, okay, I figured so. So what, you've done a lot of... I mean, you're saying... So, are you a lecturer too? Oh my gosh, you with Sonix. Best buddies, technically, basically. Or maybe you used to be a lecturer. You used to be one. And you've quit. Because of the horrendous system. And now you're also looking to start cooking.
Yeah. Let's live in a ramen shop.
Yes, right? Right?
Ah, I went to
Sure.
like buy some more banana flakes today to make some more tare tomorrow. And she's like, so what are you gonna do with this? I was like,
Nice.
wow.
There's a high chance that if you like Puyo or math coding nerd, there's a fair amount of overlap. It's sort of TGM and what comp sci was it?
Yeah, TGM has a lot of comp sci people.
Yeah. Also, if you Puyo's also like you're totally a furry as well.
That's why I don't play Puyo.
But also you've interacted with a bunch of furries now, so you're totally a furry too.
That's not how that works.
He has also made furry faces before.
I didn't realize I was making furry faces.
He used Absol instead of 3. It was funny. Oh, Bruno's a furry too, so like you're also a furry, just by default, right? Because you two have such a good relationship.
Don't think that's how that works.
You're welcome. Anyway, sorry, Bruno. I was a maths major with economics minor. Really? I had no idea, Whooper. See, I thought you would have done a comp sci sort of thing as well. Very cool.
Instead, he can feed a family of 4. Old math jokes. Or old jokes about math majors. Way to feed through the math major.
Okay. 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 I see. Oh boy. Well then, January 5th, 2018. That's crazy. I figured so, but I was just like, what the heck? How do you know all this maths? I thought you were just some another Puyo player. Gosh, I need to drink some water.
Stay hydrated.
Yeah. Well, many people watching stream just end up being furries. That's nice. Good to know I do good work. That's not a disagreement, is it?
No.
A maths grad student. Oh, okay. Right.
I'm gonna guess in the pure side of things.
Was it? Let's find out. Oh wait, we're just gonna start like asking Joe today. Oh, you finished grading your multivariates variate finals. Oh my gosh, perfect timing. Wow, right?
Well, my assumption on the pure side of things is the reaction to applying mass earlier,
Ah, yeah, no. That sounds about right.
which is a very pure math person thing to have.
Yeah, I've always felt like that too. There you go. So, that's kind of funny. That's crazy though. Thank you for the help, seriously. Like, you guys are doing so much for me. You have no idea. I mean, you probably have some idea, but anyway. It's just nice, you know. I'm very thankful. I'm very lucky. A lot of people don't get this opportunity, and it's like they're just dying. But again, like I'm doing my best to kind of spread this knowledge to my friends and stuff afterwards. So it tries to help out. I try to help out, sort of
Nope, never mind. Joe is insane.
redeem me for stuff. Let's see here. Just
It's
finish.
my
All
favorite
right.
undergrad math course.
What? See, the thing is, I can see Dr. Payov's very excited about it. I'm sure
He
you can get
is.
excited. It's just a matter of wrapping your head around it. Like linear algebra was kind of like it wasn't on a scale, but it was sort of like this is really abstract and weird at first, always as well. But
I
like,
think Linear just way better than multivariable calc.
mm,
I think
well,
discrete's the best one. I'm definitely not
discrete's
biased.
super cool. Um, but yeah, I think yeah, it's just doing it is tough. But I can see that there could be enjoyment for it. Like this is cool stuff. It's really hard for my brain to work with it, but it's cool. Like
Sure.
look at this shape. You're
Yeah,
doing
it's
this funky
comic.
stuff. You're defining it in one variable, and then you're gonna find out an integral that involves this sort of like oh.
Yeah,
Anyway, I'm not like hating on this stuff. It's just
I am.
difficult. And yeah, you're allowed to, but you're like also just basically a student at this point, so it doesn't matter. Let's see. You're not a furry yet. Exactly. It's always yet. At least you don't admit it yet. Could be closet furry. That's okay too.
I'm definitely not closet furry.
You say that. But anyway. um CS graduate, but I consider myself a math person because my research was mathy. Ah, okay, that's cool. Very
I'm a
nice.
math grad, but have lectured in CS.
Yep, that's right. That's so nice. In general, yes, exactly, everyone. Anyway, let's figure this out. Right. Also, Yoshi, what does this mean? It's this. It's this fun thing. Fun, 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 fun.
I did actually lecture the algorithms course at Newcastle.
Woo!
That was my fun thing to do.
Xenix is pretty cool like that.
Anything that's not solvable in polynomial time is actually way more fun than the polynomial time stuff.
Okay, so this is all just like we made an attempt.
Yeah.
We're sure not working. Okay, so it's this and then the derivatives of this, which look a lot more workable. So x is cos t. You know, I think if I
Game
just
before everything's solvable. Everything NP is solvable. In polynomial time, we just don't know how.
But-
Right, carry on. Talk to your chat.
so we'll just
I would-
find the derivative of this now.
While you're doing that, I'm going to continue rambling about CS.
Ah, yes.
I would love a non-constructive proof that P equals NP.
T cos
Send
t.
those CS people insane.
And this is root 2 cos t as well. Right, so if I do this, we end up with a result of the integral of minus sine t cos t
I had to explain to the deputy head of
plus
school
root 2
who wanted to do some research
sine
on
t
some carding thing why we couldn't
cos
like just code up the solution, and it was because it was in like P sharp. The problem was in P sharp.
Take root to cos t.
The vertical vector notation brings me pain.
Sorry, I don't know how to do the dot product by looking at whatever other forms you do it in. It's so weird for me. Like I
Oh,
don't.
actually, yeah, that makes sense.
That's why that's why I do dot and cross, right? I showed you the cool cross trick.
Yeah, yeah,
It's like
yeah,
that's
yeah.
why I write it like that still.
Ah,
Joe, do cross product like that? Or you're like determinant guy, right? Because everyone's all like, oh, when we teach our we must do determinant. But it's like it's just this, take this, and this one, take this one, and this one, take this one. It's easy. It's a good illustration. There we go. Anyway, you're doing the determinant. Yes, but you can look at it. You can look at the. Shush. The determinant is just. You have to write it out in the determinant form as well, though. Whereas, if you just look at the two vectors, you can see the cross product. Whereas, like, when you have it in components,
just
you
gonna
have to
draw the
write the
same
whole
picture.
determinant. You're not wrong. But anyway. Yeah, so it's plus root 2 sine t cos t. Oh, sorry, that should be 2. That should just be 2. It's 2. It's 2.
You just look at it, chaotic.
I don't know if that made any sense to anyone. A, B,
Makes
C
sense to me.
times D, E, F is equal to C, E. No, sorry. It's wrong. That's not B.
Just look at it, Yoshi, come on.
BF takes CE, which is this one cross this one. And then this one cross
Yeah.
this one. I thought that's why it was called the cross product. Because I saw this, like, straight away. Just because
Definitely not
it's
because
just
it's determined to make the whole bunch of crosses.
I just so happened to. Is that why? Is it
I
because
have no idea.
like I actually don't know why it's called the cross product.
Not aware.
Like I figured it would be something like a normal product or something, you know, like something to do with what it ends up doing, but and this one across this one. There you go. That's how you like you can look at it and see that, but I don't know. Let's see.
Yeah.
That's a mess. What do you mean a mess? You
I
just
know.
look at it, and the thing is, you wouldn't draw the lines. You would just do it. It's because everyone was like, oh, it's this formula, which is, you know, obviously also gross. No, sorry, that's not even right. Oh no. If you're doing A1, A2, A3, yeah, it's A2, B3 take what A3, B2. And then I was like, no, that's just taking diagonals. I think that's where I saw it. It was when I saw the algebra, and I was like, no, don't remember that formula. Look at the terms.
If anything, it's normal to choose normal as your example of clear math vocabulary.
Normal.
There's a Wikipedia page for like list of things called normal, right?
Yeah,
of
there surely would be. Normal vector product. Dot product, right? You have dot product and then you have... I don't know. It can't be based on notation, right? They didn't just introduce it as, oh, it's a times, so we'll call it cross product. Oh, maybe it did, because dot product is... I don't know. I don't know the history behind that. Don't remember how to do cross product? Yeah, I showed you. Oh, it's determinants of mine. Oh, yeah, there you go. Okay, fine. Fine. Talk about your determinants.
Alright, yeah, there's a normal in geometry, a normal basis, a normal bundle, a normal cone, normal coordinates, a normal distribution.
Oh my
I
gosh.
don't need that. Normal equations, normal extensions, normal families, normal functions, normal invariants, normal matrices, normal measures.
Normal family is a
normal
funny thing
functions.
here out of context.
Uh,
Oh, whoops. That's
normal
right.
operator, normal order of an arithmetic function, normal polytopes, normal ring, normal scheme, normal sequence, normal space, normal subgroup.
There you go.
Totally normal to call things normal.
I think it might be worth getting a drawing tablet after all.
Right.
If I'm gonna stream this stuff, then maybe. And like, I'd be happy to give people maths help on stream as well. That's something I've always thought about doing. Ever since like I started streaming, I was like, I would be happy to give people help as well. But I don't know how many people would want to. That's fine.
So why is it called a dot product then, Yoshi?
Why is it called a dot product?
Yep.
See, that's the thing. I'm like, I don't know. Maybe it's because Like, it just feels
Well,
weird
we're
to
going
have
based off of your cross, right? Your cross definition.
B. Instead of crossing, you're going across.
Yep. Sounds like you're still using the word
No,
cross,
no,
not
no,
dot.
no, no. Instead of making a cross with your calculations, it's just this times this time. Because dot is used for
Right.
multiplication,
Hate you.
like normal product, right? So you do this one. Like, it's just this times this times this times this. So it's a big dot that represents all of the dots between them. Let's see here. Hi, Links. Welcome. That's nice. The normal definition of normal is not normal. No, it's I'm waiting. In 1881, Josiah Willard Gibbs and independently Oliver Heaviside introduced
Heavy
both
side.
Heaviside introduced both the dot product and the cross product using a period and an X to denote them. So it literally was because. Okay, alright. I guess the joke isn't that the normal product. Yeah, the normal product. Look, I was just trying to find an alternative, okay? It was just an example. That's
I
what all
think you should
maths
just
teachers
finish the
say,
question
right?
so we can get in bed.
I don't want us to do another one. I want to do 2 questions today,
What
right?
do you mean to another one? It's already 12:30 my time.
Well, what's the next
How
one?
long have we been
Calculate the work
streaming?
done by a force. I don't know. Well, there's an equation for work, and if it just requires parameterization, again, then we could do that. Now that we know how to parameterize stuff, because Joe told us. Anyway, so it's this derivative. What are the bounds? 0 and 2 pi? Is it? Because
Yeah,
it'd
probably.
revolve around that, right?
Yeah. Yeah, that makes sense.
How do you evaluate this? Oh, you
What do
can
you mean
group
how we do
you
it?
can group
Just
sine t cos
integrate it.
t's. Obviously.
Yep.
Okay, actually, hold on. How does this simplify? I want to see that first. Uh, this is 1 sine t cos t, so it's 3 sine t cos t. If I'm not mistaken.
Oh, that's horrible.
Take 2 root 2 cos. Hold on. Oh, no. You take the cos t as well, of course.
Yep.
Oh. No, I don't do maths. 1. Take 2. That's a 3, right?
That is a 3.
That's how that works. Ah. Oh,
Yeah,
that...
you're missing the T.
Yeah, you're right.
I don't like that you don't bracket your T's on your sines and causes.
Yeah,
That's
when it's
nonsense.
just like one thing, I usually don't. Oh well. No. Usually when I write it
You just write
with just one
f
thing.
x without the brackets around the x.
Hmm. Yeah, well, I'm not writing my vector sign either, so.
Yeah, who cares about this?
Also, this reminds me of the whole like master KVOM, the whole
What's the key? Oh, right, yeah.
because they look nice, which was
Yeah.
deconfirmed, but we can forget about that.
What do you mean deconfirmed? What's the real reason?
It was like adventurer, Voyager, and stuff like that, or something. Stuff to do with space. So it was like, not adventurer, but like Voyager, I think was one of them, and stuff like that. That's what they stood for, apparently. Miharu said it on the official Discord. I don't know who would know. Maybe you can ask. Maybe we can ask.
Yeah,
Alright. But like,
what to do that.
apparently it was a thing. Or maybe Miharu's just making up lore for it now. I don't know. It could be whatever. Let's see. Normal. Dot product is component wise, cross product is everything else. Yeah, that's what I mean, right? Dot is component wise, so you're doing a big dot to represent all the dots for, as in if you're just multiplying them normally. Mathematicians are selectively creative. Yeah, of course. What's the vector d? So this one can be written in the form. Also, is there an important thing behind this circle here in this question? Like I know you can apply stuff.
As in the circle on the integral.
Yes.
Oh.
Like, I know it's the whole circulation thing, and if it's conservative field, then it's 0, but is it, like, used outside of that? I don't think my notes here that I've written here say anything
I know
about.
it's used in complex analysis as well,
Okay. Interesting.
but basically the same thing.
So, the reason why I've got it here, you can write it in the... And this is what I've used to evaluate this. The reason why I've done it this way is it's the function with each of its with the components parameterized with respect to t dot, and this is where you take this derivative with respect to t, and you write a dt to cancel the dt, because that's obviously how it works. But yeah, you take this function's stuff with respect to t as well.
Chaotic, I'm right there with you. You got all of this stuff.
Yeah, I don't know, this seems kind of ridiculous as well. I suppose we could have checked if f was conservative. I suppose we could have, but it feels weird to like have a question like this and be like, oh, it's conservative, it's just 0.
That's why complex analysis is so good. All the poles are outside, just 0.
Ah,
Like, not even joking.
that sounds delicious. How would you even evaluate this?
What do you mean? It's just an integration by parts twice.
See, I'm thinking about that, but can you take out the cos t and then
I would do it as 2 separate things, but I'm sure
can
can
you
do it that way.
take out the cos t, substitute u equals sine t, you have a cos t dt, and that's your
Maybe.
u dash,
Maybe.
right?
Yeah, maybe.
I don't know if I'm seeing it correctly, but that might be the goal, the idea. Yeah.
Okay, yeah, Joe confirms. Nothing wrong with integration by parts twice. What I'd actually do is use Wolfram.
Yoshi's version. I'm glad I can provide useful.
It is cool when you do things like that.
It is, right? Oh, not V, sorry. Oh, I guess I should write D. D is equal to cos t dt. Nice. Oh, that's so good. Oh, I should probably like...
Everything
finish?
integration by parts problem if you try hard enough. You always integrate with 1 times whatever you're trying to integrate.
Yum yum. So what does that even give us? It's 3, you take 3. Oh, we could have even taken the 3 out. Yeah, I'm taking the 3 out.
It's the SS0.
No, please tell me you're joking. So it's you take root 2. Which becomes half u squared. Take root 2u. And this is cos a sine squared. Oh my gosh. All sines are 0. Should it be 0 to pi on 2? Like, should it be 4 times 0 to pi on 2? Is that like a general thing? That thing's always confused me. When you do triple integrals and you do it from 0 to pi on 2 and you're like restricting it to one region, I'm like, shouldn't it be like 8 times or 4
No,
times
we're
or something?
surely going around the entire circle. It's gotta be 2 pi.
Right? It feels like that because it varies differently for different... I don't know, maybe that's just... Right?
Yeah, no,
What
it's
is
gonna be 2 pi. Joe did this question earlier, right?
Joe said that this was how... He didn't tell us about the bounds. We just
Right.
assumed we were right, and he didn't tell us.
Yeah, we didn't get corrected.
The period 2 pi, the first time was period pi. Second time period 2 pi, 0, 0. Maybe learn something along the way? Pretty sure the bounds at 0 to pi. Ah, they are? Okay. So, I mean, regardless, you have... Oh, no, it would still be fine, because sometimes you can do it... No, okay. Even if it's cos, then it doesn't have any meaningful result, doesn't it? Maybe? I don't... I'm trying to see if there would be, but I don't... Anyway, if all the signs are 0, then this is just 0.
Cool.
And so maybe if we checked if it was conservative, then we would just...
Yep, yep. Would have
Should
made the
we do
question
that?
so much easier now.
Do that instead of doing the second question.
The second question is surely not going to be conservative. Why would they ever give you
No,
two
but like,
conservative
do you think doing this sounds fun? Where is my
no,
work
that's why
formula?
I'm going to go to bed. Because it's already, what, 1:45?
Work is equal to... Oh, work is just doing a line integral, isn't it? Yeah, yeah. Work is line integral. I'm pretty sure I wrote that here. Yes. If your f is cos t, you want to make a full circle.
We don't even care if this is like conservative or not, right? Because it's not gonna be closed.
No, I'm talking about this one. Should we check if this was conservative and see if that would have given? Because that would mean that our answer's right as well, right? It's another way to check.
Right. Yeah, no, I don't want to do that.
I mean, if you want to go to sleep, maybe I can do that while you're...
I don't know.
It's a smallish task.
I'm not even gonna go to sleep. I'm gonna eat food after.
Because all I have to do is I have to take the derivatives and equate them. That's it.
Yeah, do that. Yeah, do that.
Yeah, but I'm just double checking. Joe, or I mean, Xanax, if you even agree with this, but I don't know. Work is just this line integral using with these
Yeah, I don't know.
things.
I don't know geometric.
Oh, they even
interpretation.
parameterized it for us. That okay? Yeah, might be able to just do that without too much trouble. Actually, 5 seconds to check. Yeah, right. Isn't this fun? That's definitely her voice.
Yep.
Okay, so yeah, just confirmation on that, and then we'll go ahead and check if it's conservative. This was question mastery check 5.9. MC 5.9.
Haven't seen Connor get past like 3 minutes yet.
Um,
I mean, I'm watching your stream and concentrating on masterclass.
100%. Yosh, guess what? What is it? Do tell, do tell. Okay, let's see here. So we have... Wait. Wait. I assumed that we were
Yeah, so did I.
integrating just and
So guess what I'm gonna do? Gonna go now.
wait, so does that just mean we were meant to integrate y? Wait, dot product of... So we parameterized it, and then instead of our vectors being all of this, like all of this x, y, z, it is just 0 sine root 2 sine t take 1 and 1. Is that what this is saying? I don't know if that's what that's saying.
I forget what you said, but yes.
You're like just substituting,
Yeah.
right? Because x is... Did you not even use f? We didn't use f. I was
Not
just
use f.
taking this x, y, z as our f is just x, y, z.
It's like we didn't go back and read the question after we did parameterization.
Yeah.
We
that
learned
was
an
a...
important lesson today.
That was a fun little experiment. Let's control S that. So, I'm sorry. Look, I found a cool integration by substitution.
You mean a sexy integration by substitution?
Yeah, and you know that when you do something that has that adjective used with it, then you're not going to get 2OS, then actually everyone loves it and you don't get in trouble because it's just that cool.
Yeah.
Sergeant, thank you for the follow. That was 5 minutes ago, but I forgot to shout out. Thank you. So how do I interpret this? Does that mean that F literally is just
I think so.
root 2 sine t take 1? Okay. So okay, it's this 0.
Speaking of TOS, when are you gonna do a hot tub RMS stream?
Oh no. Oh no.
The idea is planted in chat's mind now.
They
Hang on, is that last one?
is it because Z like
Oh,
isn't here, right? So it's just one.
Yeah.
So you needed to come up with this whole parameterization to make like this make sense, and then you just use the values that are applicable to this vector field. Well, I mean, we can integrate this like quickly as well too, so it'll be alright.
Why isn't the first component not the second component?
Okay.
Why
Y
is
is
it
in.
associated
Oh,
with
you're
Y?
right. Ew. And this is IJK, so that is 1. Okay. And I'm after
Nice
that.
catch.
Yeah, that was good. Okay. Thank you. 0 2 pi dot of this. Let's find the derivative of this. Wait, so it's here's the thing. It's
No more stuff on your rule.
oh my gosh, it's terrible. Hold on. You're finding the derivative of this with respect to t, not the function of f with respect to t, which also confuses me. I don't really understand that. Does that make a difference? Or is it still representative of like no more circle in the integral notations you don't do it anymore? Really? When you parameterize it, it's not circulation thing anymore? Okay. Go sleep? I'll sleep after this question. We'll do this tomorrow, unless I do it like at uni somehow. We'll
You
see.
mean somehow?
We'll see. Oh, I forgot this part was. This part wasn't that important. That's. Oh, hold on. Only over a curve. What do we? Oh, okay, right. So if you parameterize it, it's not. Okay, gotcha. Maths is poison. You must fight maths with sleep. Maths isn't poison. What are you talking about? So is this with respect to t actually just like is this expression here? This one. Root 2. Was I right in saying that it was just this? 0, 0. 2 sine. Oh my gosh, that's disgusting. We can still apply the substitution here. It felt like that was a very natural part of the question. So this is not r dash of t. What is r dash of t? Because that isn't that the component a component of f, but I don't understand what that even means because that feels like that is just f, but that's not f. What is it actually? What does that actually mean? It's not right. I'll do that and sure, blah. So it's not this. What is it?
Right. So R is what we found earlier with the substitution, right? Oh, with the parameterization, right?
Oh, is R the set of x, y, and z here?
Yeah, yeah. And then you plug that into your
Mm.
f, I guess.
Is can you take the derivative of a vector? Is this correct? Oh no, that's what that's saying. Oh my gosh, of course. I'm mathematics. Returns.
All right. Can I add? I mean, I'm still watching our stream and
No ads. You're trying to figure the tangent vectors are. Ah. You're trying to figure out how the vector field acts on the curve. So you take a dot product, the projection, with the vectors in the field with the direction the curves go right, and the derivative. Yes, I remember reading this. Yes, thank you for clarifying that. That's actually really, really, really helpful. That part of the theory, like that's making sense now. That's making sense. Was it not in the notes where I specifically remember? Yeah, I don't know. It might have been during the.
Oh, there's like 100 pages of notes for this chapter.
Yeah, it might have been in the lecture that he mentioned that sort of relation. Yeah, that's helpful. Thank you. Yeah, he was talking about the whole like the space and directions along a curve. It's tangential. It's yeah. I couldn't wrap my head around that. That's making a bit more sense. What are you doing? Me mess with friend. What about you? Yeah, just show her this. Be like, I'm learning this. I'm learning multivariable calculus. We're working with vector fields and line integrals. Great. Yes. Get your mom to teach us multivariable calculus. Right? Radius mom will be the one comes in clutch. Late game yeah, it is, right? This is late game. Well, I mean, it's late game of the introduction to it, right? Although, I mean, it's the farthest that
Yeah,
people
this
get to,
feels
so is
like
it
the
late game?
tutorial, right?
Here's the thing, like, if most people get to it, is it like more like this is the end game of the main everything else is post game because postgraduate studies.
Yeah, yeah,
So
yeah, yeah, yeah.
yeah, this is main story. Yeah, no, it'd be funny though, Rainy, to just say, oh, can you teach me about
Already
this?
better at gamification in a lot of the lecturers who try to gamify stuff.
See, this would be such a good way to do it. You make Year 12 sound like a final area of a game or something, and just kind of design the whole everything around that. Wouldn't that be cool? All the stuff that you learn is like picking up different equipment and armor. Very cool. Anyway, um, let's see here. Hi, Loonsters. Wow! What the heck? Hi there, hi there, hi there. Nice to meet you. Very. I've never seen such a formal Twitch chat introduction.
No, have I?
Let's see. Next would be differential geometry, which is offered in some universities. Differential geometry. Is that like the next step of multivariable calculus? Is that what you're saying? You said next, so it's like probably.
I think like years ago, differential geometry with respect to general relativity was offered as
The
an
only
online
thing
course
you
at my
should be
uni.
respecting too is t when you differentiate this. Anyway,
Yeah.
I will write this now, and like
Good. I'm
surely,
gonna pee. I'll be back.
yeah, go do that. Um. Anyway, it looks like you can still take sine t out of this. Should I just preemptively do that? Sine t. Oh, you can't now. No. Are they actually doing this to me? Hold on. So this is root 2 sine t. Oh my gosh, that's gross. Sine t cos t. Take cos t. Oh, that's 0. Plus root 2 sine t. Take 2. Oh my gosh, is this actually the integral now? How do I do this? Root 2 sine t gives you cos t. Ah. No. I don't see it. What do I do with this? This looks like nothing. Did I mess up a calculation somewhere? Is this meant to be like the same term and then you take it out and it's like really cool? And then you can do the sine t equals, like cos t equals negative sine t. Man, you have to separate the integrals. No! Surely there's something I can do here. Surely they designed this problem in a way that you can just do something cool instead of having to. But Joe... What if I did make another mistake? I need to check if I made a mistake again. Why is that? I probably should should check if I made a mistake. So this is cos t, which becomes I didn't take the derivative of this. I didn't find the derivative of this. How is no one catching this?
Because I haven't been paying attention for the last hour.
Help me. Help. No, you're not obligated to tell me. You can just base off it. That's okay too. Minus sine t.
I thought of a better reason, just in my opinion, about why I help you, and it's just to delay you from like getting better at death.
You know what? I'll
I'm
take
actually
that.
sabotaging you, not helping you.
You know what? I'll still take that. That's okay. You can deal with that.
Joe, I'm too
reality.
busy berating you to actually check your work.
Hey, you sound like Xanax. You guys really would be best friends. I love you guys, by the way, but you know that's kind of you were kind of. This is the sort of work environment I have to put up with being lucky. Science.
Joe, contributing you. Well, I cook you both ramen.
Ah, now I think we're getting somewhere.
I have so much pork belly in the food. It looks so good.
Well, now I
I'm
can.
very keen to eat it
Oh.
tomorrow.
I have a sine squared. Is sine squared the one that turns into one take? Cos square. No. What is it?
Thank you. Thank you, President.
Is it the cos 2t thing or something? Whatever. What is this become?
Oh.
Sine squared.
Why are you worried about that? That's an easy integral to make, isn't it?
What? How?
No.
How do you do
Never
this?
mind. I'm an idiot,
Sine
yeah,
squared,
sorry.
you have to do the funny thing. That's why I'm looking for the identity. Okay, is this correct now? Minus sine t, root 2 cos t, root 2 cos t, and this comes from cos t, root 2 sine t take 1, root 2 sine t take 2. Okay, yes. This is the thing. Root. This is y, and y is root 2 sine t take 1 And that was 1, yes. Cool. The
Can
evil
you turn it
identity. There you
into?
go, it's that one.
Can you turn it into sine of 1 minus cos of integration by parts?
Settings.
Or would I just look at what it is?
No, I've been trying to do this for ages. I can't give up now.
I meant just the sine squared one.
He wrote it.
Oh, well,
Thanks anyway.
yep. I did. Yep, no, I totally missed that line. I read the evil identity one, but not the like actual identity.
That's okay too. Okay. I haven't
That'd
saved
be
this.
1 on 2.
Oh, hold on. Where?
Left.
Oh, that should be... yeah, everything divides out by 2, you're right.
Look at me actually helping for the first time in an hour.
Thank you. My school teacher made sure we knew these, and I can't decide if that was time well spent. I think knowing the trigger entities is actually quite helpful. But, like, that's also the same as saying that I should be able to
When am
recognize
I
the
ever
Taylor
going to use
series
that?
expansions of things and say that this is the Taylor series. And I think it's probably the same sort of deal where I will disagree with it for a while and then I'll get good at it and say, yeah, this is helpful. But, like, I also wouldn't recommend anyone else to do this. I don't know. Tough stuff. Is this part 2? Hold on, have I already saved this one? Oh, I don't remember what the stuff was. No. No, this is 5.9. Right? 5. SP 5.9, yes. Part 1. Okay.
I feel like in high school I knew trig identities much better than what I currently do.
I mean,
I
that's
know the
fair.
cos squared theta plus the sine squared theta equals 1.
As long as you know the quadratic formula, you're fine.
Yeah. We didn't struggle with that the other day.
I used quadratic formula in my assignment, and it was really cool that x1
Yep.
equals x2.
Yep.
That is all. Oh my gosh, Joe, that's actually what I'm talking about, though. Yes. It's knowing the Taylor expansion so that I can and recognizing the different types of distributions so that I can say that an integral equals 1 or whatever. Stuff like that. Or, you know, just being able to identify different distributions. That is important. I'm gonna have to get good at that. I'm trying to figure out a way before the exam comes. Because it's like, if I'd known that from like early on, I would have been able to find a way sooner. Alright. Let's do this. Uh,
It definitely feels like normal time. I'm so excited about cooking stuff tomorrow.
so you're gonna say excited about finding the solution to this problem?
No, I did not care about the solution to this problem.
Mm.
I've been over this problem for how long have you been streaming?
No, we were looking at the other stupid stuff that made no sense and
Ah,
was
yeah,
like
true.
seemed kind of useless. At least this one goes somewhere.
Yeah.
Like I felt like I was learning when I was doing the questions, so it's probably a good thing.
Yeah.
Thank you, like Joe, seriously. Sine is 0, cos t, 2t, 2 pi, cos of 2 pi is 1. 0. Take 0, plus 0, plus 1. So, is this our answer? Is that seems to
Hopefully.
cancel like this could be completely wrong, but honestly, I'll take
Like,
that as an answer. I'm actually happy with
Shuruchu
that now.
pie seems like an answer.
Yes. Ah, jeez. Has the ring of truth.
Yep, no, I totally agree.
Nah, yeah, me too. That's actually. We'll see
If it
when the
doesn't have a
answers
root
come
2
out
and
for
a
this
pie
one
in it,
next
then...
Wednesday. What were you saying?
If it doesn't have a root 2 or a pie in it, then it's not the answer.
Oh, to be fair, a lot of stuff in this, like circular stuff, ended up not having pies, and everyone
Oh,
was
did it
like,
have
"Oh, that's
0
cool."
then?
I don't remember.
It's gonna be 0 or something with this, like root 2 or a pie or
No,
something.
no pies. I don't remember what this was about. Stuff didn't have pies in it. Well, I forgot. Anyway, that's not important anyway.
It must be squares.
Mm,
Really good pies.
mm,
It's like we're not square. Yeah.
mm,
It was a joke.
mm. I'm laughing too. I'm just too tired to.
That's good. Yeah.
No.
Mm.
Um, so we did this question.
We did this question probably. By we mean you and Joe did this question.
You still helped.
Yeah, I guess I found that one on 2.
Yep.
Big contributions.
Always. I'll erase for now, and we'll check the solution next Wednesday. But I'm like satisfied that I can just leave that one there. That's actually okay. Man, that's the thing we actually completed, but like I guess discussing this stuff was sort of necessary. It had to come up at some point.
Yeah. Bruno, infinite loops, fun.
Oh, Bruno. It's okay. Our progress today has felt very slow as well. So we're all just like slowly creeping through.
I have no idea, like... Ooh, yeah, no. Legacy code from any number of years ago. Just bad. I have no idea where, like, Joe is from. Like, I can't, like, pick the mannerisms.
He says math.
No, I mean, like, location.
Yeah, no, I'm saying math. So
Oh, he says math, right.
so it's not.
It's not a, like, real country.
Generating functions. Yes.
No, we should play GeoGuessr together sometime.
My geography is so shocking. I would
Yeah, but
just
you don't
guess random
need...
countries.
No, there's so many tricks.
Like I don't even know what country names are. Like, what is
Oh, we should fix that.
Yeah, true. I probably should.
Do you know how many countries are in South America?
I don't.
Ooh. It's like 10,098.
Like a lot of the time, I'll be like, literally, like, can't figure out the relative position of Russia compared to us right now. I literally know that like, if you're
Alright, to be
moving,
fair, Russia is quite a big place.
yeah, okay, but like if you move north, right, you're going into
Yep.
Asia, and like I only know like the closest stuff to us, so I know about Indonesia, Singapore, Malaysia, Vietnam. Um, then China is just off of that. If you move left, I believe, right?
But,
Left.
yeah.
And then I don't know what's above there at
Russia.
all. So above that is Russia.
Yeah,
And
Russia
what direction
extends
do you
all the way
move
over in...
for America and such?
So if you move east from there, east from China, you hit Japan.
Okay. Yes, that one I know as well.
If you... Well, that's a overgeneralization. You probably hit like Korea and stuff as well.
Yeah.
But yeah, Japan's like main country. then if you go east from there is, yeah, the US has to be next, right? Like the North American.
And
South
then is
American,
Europe then
then
further?
Europe's further east from that.
Yeah.
Or you can go west from China and hit Europe.
Gotcha. Canada lies where?
Canada lies above America.
Above
Canada's
America.
America's hat.
Above America.
Yeah.
Gotcha. See? There we go. I'm learning. No, I'll forget this like tomorrow, but I'll slowly. I need to eventually learn it, so it's nice to
I do. Yeah, let's see if I
hear stuff.
state map Texas.
Um,
Let's see if I
where
can
are you
like
from?
pull up.
It's 10:09 a.m. where I am. Wait, same time zone as Shocky.
Alright, are you?
Hmm.
No, that's a different time zone. The Shocky.
Isn't
Shocky
it an hour and
is
a half?
east. That's mid.
Hour and a half.
Isn't it 11 for Shocky at the moment?
Oh, 2.5. Dang. I can't do maths. I mean, don't forget I said that.
Alright. So what state is highlighted here, Yoshi? Oh, hang on, are you even like looking at my stream?
Well, I mean, I haven't been checking it for. No, I don't know any states.
You don't even know what this state is?
Hey, it says on the top that it says Texas. I
Right,
use my
that isn't in
problem-solving
Texas.
skills.
Alright, what about this one over here?
No, I don't know. I don't know where
Alright.
anything is.
Alright, so this one in here, this one's Kentucky.
Okay.
You can tell this because these states here, these like very vertical
Mm-hmm.
states, look like a person wearing a chef hat, and this looks like a frying pan, and this looks like some chicken. And
I
so,
see
like,
that. Thank you. Okay.
that's yeah. This one over here is California. This
All
one's
right.
Alaska. This is Hawaii.
All right.
I kind of forget what's going on up here. You're from the chef hat? Oh, I don't know where the chef hat. What the chef hat is.
Question
Yeah, let's
marks.
see if I can.
Minnesota.
I was gonna say Minnesota.
Dang.
I don't know why I feel like I had Minnesota like lower. One of these is this North and South Dakota. Maybe.
Geography class begins. Without
This
the
one
break.
maybe is Nevada, I think. This is Florida.
Oh, okay. Oh, other side, he says. Okay. USA states confuse me. I don't know them at all, so yeah, I don't know. At least you like have some idea, and they're confusing you, Bruno. I guess. Oh, for grad school.
Cool. So, are these two? No.
Is that close
Like this
stuff?
whole northeast thing just confuses me. There's too many things going on.
Yeah. We can close this, and
Wisconsin and Illinois.
this.
Georgia's somewhere around here. Let's see, which one am I going to pick for Georgia? This one. This one's Georgia.
Oh, I can close this. Yeah, that was. That's.
Richmond off of Wisconsin is part of the glove state Michigan. Copy this. No. This one here. No, this one here.
Mitten shaped. Go sleep. I'll sleep soon. Don't worry.
Oh right. Yes. Yeah, no, that's gotta be Michigan. That makes more sense. Like things, I think. Pennsylvania? Yeah.
Snipping. Do you know Windows Shift S does the same thing? Windows Shift S.
Yeah, Yoshi doesn't know keyboard shortcuts.
Oh, come on. I know, like, a lot. Oh, okay. So this is snipping. Oh, that's
Um,
great. Thank you. Can you locally copy from here? Is this copy? This copy, yeah? Cool. Windows Shift S, thank you. That's gonna save me. Using snipping tool now. Wait, does it say that you can access it from that in this? Oh, you can. I forget why I never caught on to that. I think it's because I just never really started using it, and then I just defaulted to doing this. But that'd be more useful for like on the dot, on the spot, instead of having to go there. Thank you.
I'm always so embarrassed when I take photos of my computer monitor.
Oh,
It's just dirty and I never clean it.
ah, fair. But we have
Perfect.
this though. You mean like your desktop, or like just your screen in general, like your whole screen,
No, my screen. Just from like,
just like the tabs and
um,
stuff?
I don't know what. As in like, dirt on the like screen itself.
Oh, you mean like actual monitor,
Yeah, yeah, yeah.
not on? Okay, yeah.
Yeah, yeah.
Immediately into the clipboard. Yep, just like snipping tool. No shift S. Yeah, yeah. F12 print screen. But the problem with that is that it prints screens both
Yeah.
screens. On my laptop that was
Printing
fine.
too much. Why is it so hard to resist doing that? Because I do that one. I have it, and I
Yeah,
do that
exactly.
one.
I figured it would satisfy you. Okay, can we call this a vector field, right? So this one goes across this way. No, I don't. Take a photo of your screen with your phone. I think that might have been what the term. Alt print screen. Yes, I know about alt print screen actually. Um, but much of the time I need to take like pictures that also include other stuff. Actually, I got a notification just now, which might be funny to read. Let's find out. What does this say? 64. Oh, I always forget what this kanji means. It means a version. Han, how to read it. Puyo, oh, TA. Artist. Kino, so yesterday. Me, ni, what's this mean? Caution, renewal update. Caution,
Improvement.
Shin is new. I forget what this one means. Alright, too short time. It's Japanese practice time. We're learning everything today. Uh, what does this one mean?
Then you could import that PDF into LaTeX, right?
What? PDF are you talking about?
I'm talking to Joe.
Let's take a picture of it.
My screen, email it to myself, and import it to a Word document, and then export it as a PDF.
Oh my goodness. See, all my photos and stuff from my phone that I used to have to email everything to myself, and I was like, that's so inconvenient. And then I figured out you can share stuff with yourself on Telegram, and you can literally just copy stuff from there as well, which is super handy. That's what I've been using.
Yep.
Telegram's a lifesaver. Um, what is the Indonesian practice time? We hit that like once or twice. So I mean, I tried. Chaotic, I'm sorry. That's why we should just communicate in the common language of Japanese. So this is actually a junior higher country. I actually don't know this one. This must be a radical with some other stuff. Okay, so that's Koshin. Koshin sareta. I believe that's what is it? Passive? Like someone did something over me, like without my right. I know it doesn't even say sareta to be done
Why are you
to
saying
to
right as if I
someone.
know the answer?
Hmm?
Why are you saying right as if I know the answer?
Oh my gosh! Hi Wiggle. Oh my gosh! Hello. A rate of 24. Hi. Hi. Oh my gosh! Thank you all so much. Um, we're actually finishing up soon. Unfortunately, the because I feel like right, it's a Puyo number. This is amazing. 24. Perfect. Thank you so much. Hello everybody. We've been doing maths for most of the stream. Bit of geography. because why not? And I also complain about
Ranting
unis,
about
but you know, that's a
universities.
thing. Hmm?
I said exactly the same thing. Bit of ranting about unis.
Yeah, right. And now we're just like quickly checking a couple of things off before we go, before we head off. But thank you so much. Thank you for the follow as well. された正解 what is record again? Um, um, 記録正解記録 so world record 16分25 秒 so 14:25 or what is this? Or harbor. Yeah, what does that even mean? Greater? No. Big, large, drastic, substantial. Oh, he's using it as an adverb because he's using ni. Oba ni nuri kaeru. Kaete. To repaint. To break a record. Oh, so there's literally a word for breaking a record, and that is nuri kaete. Nuri kaete. I saw in his previous tweets he was using this word, but he wasn't using the correct kanji for it, so I just didn't get the meaning for it. Nuri kaete. So I beat Yoshi's record from yesterday by a lot. And
Get
what the
shit
heck
on.
is this?
What? I didn't say anything.
I have no idea what you said.
I just said get shit on.
That's nice. That's your way of supporting me to like do better, right?
Yep.
That
Just
kind
like,
recovery.
what's the word I'm after? Like,
What is it?
um, just like motivating you to get better. I guess motivating you to want to try.
Obviously, because you want to see this content, right? Instead of death.
Yeah, exactly.
So yeah, this is like a bunch of kanji that's new to me, and I don't think I'll take it in, but it's fun to know. So if it comes up again in more speedrunning, then you know maybe I will get familiar with it. Because there's cases like that where it's like really complicated looking stuff that I like won't learn forever, but because I've seen it enough, it gets it great. It's nice. Road record 奪還しました。嬉しい. So happy he's happy. That's awesome. I'm very curious. I want to watch this run at some point. Maybe I'll do that like while I'm like getting into bed. Geez, that is a big improvement. You can notice here it says 0.92. So I wonder if like he skipped a cycle. No, 81 seconds. Never mind. So she nearly 3 cycled. Maybe it's because like I got 3 cycled, right? So he didn't get 3 cycled, and that could have made like a lot of this difference. I'd say that's interesting. We'll see.
Read the entire way through. Yeah, it's just because of the 3 cycling.
Yeah, to be fair, no, he didn't save that much time here. No, you're right actually. He saved a lot of times. Oh, I wonder if it's Harpy. Could have been Harpy. That she's the funny one with the transform. All the
Yep.
things. Yeah. It could have been a good cycle on her. Because like that's a lot of time. Looks like Chico, so that's the one that clears the middle. So maybe a 1 cycle that too. I'm very curious. Very curious. And then he lost time in the quiz, of course. Okay, well I'll watch that later. For now, I should head off to get some rest and let Sonic's rest as well.
Yep.
See, I didn't keep you up till 2. I told you.
Yep, it's only 1:30.
What do you mean repaint is the verb for breaking a record, right? That's funny. While like Japanese breaking my brain. That's funny. They're kind of similar, right? Breaking a record, you're repainting the reality. It's close enough. It's not like English where the words are just completely different.
Well, you got the same word for like 20 things. Normal.
Rock. Yeah, normal. Normal's funny.
Yep.
Okay. So with that, yes. No, I'm not gonna allow you to do that to yourself. I will
Bad
not.
times.
I will not let you stay up too late. I care about your health. That's what the statement is. I
Yeah.
swear. I swear. Um, let's see. Yeah, I like Japanese. English is normal. Of course. Okay, so very high likelihood. It seemed like you guys who were here actually did quite enjoy yourselves. So Bruno, Chaotic, Joe especially. Or shout out Rainy as well. You can be study buddies. Uh, thank you all for joining today. It's been a good time. It's been nice to be able to socialize while right, like that's just nice things to do. Socialize while you're doing work. But because my hours are a bit awkward, it's streaming is a good option. Um okay. It means 1/5 of the night as well. That's interesting. You
What are we?
vocab.
What? Oh,
This word also means 1/5 of the night. Oh, this by itself
yep.
can mean 1/5. That's really interesting. Fascinating. Alright, anyway, that's enough. Thanks everybody for joining us today. We'll probably be back tomorrow with more of this, to be honest. Um, whether we're picking up directly from here or maybe we're doing some physics or it might be something else. But like most likely, if I'm doing stuff on stream, it'll be calculus or physics. Linear programming networks is easy enough. Probability, maybe there's a probability questions to go through, but maybe not. We'll see. But yeah, thanks everybody as always. Thanks to Xenix.
Yay, me.
Yay. The complexity. What is complexity theory? No, I shouldn't
The
ask stuff, right?
algorithm runtime.
Ah, yeah, right.
When Shocky does it, and we get Shocky on stream to do it.
Yes, we'll get Shocky. I did a little bit of complexity, that counts, right? Anyway.
Go to an algorithms course. Drop your physics to computer.
It's too late, sorry. Do you want to ask that question? No, I don't. Actually, I am willed to, but the rational part of me says
We've been
don't
late
do
by
that.
2 hours.
Oh,
I wanted
golly.
to end streaming like 2 hours ago. We're already at that.
True, true. This is like a one more time with death,
Yeah,
except
yeah.
it's even worse. Twitch chat lecture? I would take that. I would happily sit here and be lectured by chat. Like, it lets me get pretty good feedback. Lectured by 1,000. Wonderful. Wait, that's like integration, right? You take like
Fuck
1,000
me.
slices and you just add them all up again. You did it in the X direction and the Y direction and the Z direction. And then, anyway, that's probably enough. You're welcome. I'm funny. My friends don't hate me, I swear.
So, we're not friends then, I guess.
Wait a minute. Yeah, I love you too, okay?
Didn't I say earlier on in the stream that I hate you? I forget.
I would be surprised if you didn't say that.
Yeah, right?
Yeah, exactly. Oh, no. Oh well, everybody else loves and appreciates you, and that's what matters, right? It doesn't matter what
Exactly.
like I feel.
Exactly.
It's
And that's why you keep
all
bringing me
for the
back.
audience. Yes, it's for your entertainment. On that very pleasant note,
I think that's a pleasant note. I have value. That is a good thing.
yes, you're
That was
Gary.
the point of
There
that.
you go. There you go. Thank you all so much for watching. Thank you for the help, especially. Again, probably tomorrow will be the next time we're doing this, so I'll be around then. So maybe catch you there, maybe not. We'll see. But for now, as always, I hope you all have a good rest of the day or night. I love you guys, and I'll see you all next time. Good night.